Okay, so today we are going to study the battery management system of architecture and components of BMS, SOC and SOH and estimation techniques, right? So let us study the very basic fundamentals of the BMS, the cells module pack, as well as how the BMS is required for the for electric vehicles, and what is the purpose of having the BMS in the electric vehicles, and the state of charge and the state of health, and all these estimation techniques we are going to study. Okay, so these are the contents, the BMS, architect and components of BMS, SOC, SOH estimations. So, alright, so let us go with the introduction part. Right, electric vehicle generally contains the following major components. If you see any electric vehicles, there will be the motor, right? There will be the controlling unit circuits. There is a tractions, a battery management system, and the wiring systems, along with the chassis of the vehicle body, right? And also with the frame. So these are the parts which consist of our electric vehicle. So we have electric motor, controllers, that is a it may be DC to DC controller, right? You may have the tractions, battery systems, and we have the BMS system also, right? Battery management system, and the wiring system will be there, and vehicle chassis, body of the vehicles, and the entire frame. So these are the components which consist in the electric vehicles. So the battery management system is one of the most important components, right? We need to learn the battery management system, right? Especially we'll consider with the lithium-ion batteries. We'll consider the lithium-ion batteries. We'll study the battery management system, right? The lithium ion cells operating voltage, current and temperature has to be maintained within a safe operating area. That is SOA, means safe operation of the area should be there. Temperature should not exceed and voltage should not exceed and current should not exceed. Right. So that is how we have to maintain all these the battery systems. Right. Every time, all the time, it is in running conditions, when it is in charging condition, when it is discharging conditions, we have to maintain all these various parameters. That is voltage, current, and temperature. Right. To maintain this, a safe operation is required for any batteries. Right. So they require a protective device to build into the each pack. It's called the battery management system. Right. So each pack has to be in each cells right from the each cells. Right. Then when you connect in series in parallel, then it will become a module. Then complete module will become a pack, right? So inside the pack we'll be having the modules. Then inside that we will be having the each individual cell. So we have to monitor the each individual cells, the safe operation of the batteries, right? So which is used for the productive purpose of your vehicles, right? So that it not get overheated, it not get the short circuited. They will not be having any the burning sensations in the circuits, right, in the batteries. So that's why we have to maintain the safe operation of these batteries things, right? This about the cells, we are just talking about the cells pack. Each pack should be monitored properly, right? So we have to check its state of charging, state of discharging, state of operation, and state of health. So all the things we have to, and also we have to check about the depth of discharge. Yesterday we have discussed about the depth of discharge in the last sessions. So, all right. So here the BMS, that is the battery management system, right? The battery management system on decisions on charge and discharge rates on the basis of the load demands, right? So it depends. Usually the BMS make the decisions will be monitored by the BMS only during the charging and discharge, because when you apply the loads, right, the battery will try to draw the more power from the motor will try to draw the more power from the batteries. So it depends upon the load demands. How many people are sitting inside the vehicle? How many people are there in the inside the vehicles? So it depends upon the BMS has to take the all decisions on charge and discharge rates, right? Which is based on the load demands on the vehicles, right? So one is we have to see the cell voltage, that's current, and the temperature. So these are the three parameters you can please note down, because we are discussing more on the cell voltage, current, and the temperature measurements, right? And estimation battery SOC, and remaining remaining how much of charge are available, right, to discharge, for the discharge, and to move the vehicle for the next miles, right? That is it is based on the capacity, impedance, and so etc. So BMS is a part of the complex and fast acting power managing systems, right? So let us see why the BMS been introduced when we have the batteries, right? Earlier days we have the batteries for the dynamo purpose in the IC engine vehicles, right? But here we have the batteries without having the BMS. We are supposed to run the vehicles. Still we are just want to know, we want to learn, we want to go for a safe operation. Then you have to go to the BMS only, because without BMS you cannot monitor anything else, right? We want to check what is the cell temperature. If the cell is temperature is suddenly gradually increased, right? The cell may not be operate properly. If the voltage is exceeds or the current is current is trying to draw the more current from the cells, right? So everything depends upon the how the depends upon the loads, right? That is what we have to monitor the your batteries. So that's why we have to learn the battery management systems. So let us go with the history. Why the battery management system has been introduced in the world, right? What is the need for the having the battery management system? When you have the batteries, motor, and controller, you can incorporate all these things, all the three things, and start running the vehicles. Still, we have to go for the BMS because to monitor all the various parameters while running condition, while charging condition, and while discharging conditions, right? Let us see the history of the BMS, that is the battery management system, right? So on the 7th January 13, a Boeing 785 flight was parked for maintenance. During that time, there is a mechanic noticed the flames and smoke coming from the auxiliary power units, right? The lithium battery packs. When he noticed that one on the flight 16 January 2013, the another battery failure occurred in the 787 flights operated by the All Nippon Airways, which caused an emergency landing at the Japanese airport. See, when we not monitor the properly of the batteries, so what will happen actually? There may chances of the catching the fires, catching the flames, the smoke also may come from the batteries due to the overheating of the batteries. And that is what they have noticed in the year January 2013 and 16 also. These are the incidents which has happened, right? Another incident, if you see, then there is a battery failure in the flight number 780 flights, right? So during the emergency landing at the Japanese airports. After a series of joint investigation of the US and Japanese, what is the reason to get for getting the smoke as well as this flame and also the battery failures? What are the reasons? So that's why they went with with collaboration investigation with the US and Japanese. The lithium battery pack of B787 went through the scan and revealed that one of the 8 lithium cell was damaged, causing a short circuit with the triggered a thermal runaway fire because of the overheating of the batteries, right? So because of the overheating of the batteries, they have noticed that there is a chances of the failure of the batteries also that may leads to the short circuit or they may leads to the catching the fire and resulting in the smoke also. So this incident could have been easily avoided if the battery management system of the lithium battery pack was designed to detect the prevent short circuit. So that's why we had to go for the BMS. So this is the reason why we had to go for the BMS, means because of the failure of the battery. Sometimes the battery may failures. There are chances of overheating. There are chances of getting the smoke from the batteries. There is chances of the flaming of the batteries. There may be chances of the thermal runaway of the batteries also. So these are the various reasons. The incidents which has happened, those incidents has been noticed and observed, and they made a research, right? What is the actually happened in the earlier days and causing for the short circuit and which triggered just because of the thermal runaway with the fires. So these are the reasons why you have to go for the battery management system. So all right. So this is the one example, right? So then what is the need for the battery management system? We have to use the energy, right? We have to use the energy in a proper way. From the portable source, that is from the batteries. So whenever it is required, it has to draw the current and voltage and the nominal temperature we have to maintain the nominal temperature also for the batteries. So that's why we have to go for the battery management systems, right? So that is the purpose of using the battery management system. Usage of the energy should be in the proper way, right? How much of charge, how much of discharge, right? In the batteries, how much of energy capacity is there, right? How much of power density is there, how much of temperature is there within the specified limits, right? The temperature should not be decreased or temperature should not be increased. All right. So because of that only we have to study the battery management system. Right, what is actually the battery management system? Battery management system is a BMS, is the system that designed to monitor the performance and the state of the batteries, ensure that it works in a safe operating regions, right? So BMS will tell us about we have just designed a system where we have the controllers, we have the various parameters to measure, we have the sensing units to measure your parameters such as voltage, current and temperature, which is fed to the BMS systems, right? And BMS system will try to give the certain outputs, that is state of charge, the state of health and also the state depth of discharge, right? And the safe operating area of the batteries also it will try to determine us. So that's why we have to go for the BMS. The BMS will tell us about very clearly. We are going to monitor you are going to monitor the performance of the batteries, right? Actual condition, you are going to check the status of the batteries. What is happening? What is the things which is happening in the batteries, right? So in other words, you can say that the basic task of the battery is to ensure the optimum use is to be made of the energy inside the battery powering the portables, right? So whenever it is required, it has to draw the power from the by the batteries to the motor, right? In a very optimal ways, right? We have to make sure that usage of battery should be in a very optimal ways. Or else what will happen? There will be chances of the short circuit also, right? And also there may lead to the thermal runaway in the batteries. So because of this reason only we have to study the BMS, right? So if the things could not be sorted out, right? If you're not monitoring these kinds of the various parameters, the thermal runways are short circuited, so that leads to the damage of the your batteries also. The risk will happen for the damage, right? Which is be inflicted upon the batteries. The battery life will get reduced. So this should be to overcome that we have to monitor and control the battery during charging and discharging processes. All right. So this is actually the common the definitions. Why we have to go for the battery? We have studied the histories also, right? From the history, we have understood that we are going to learn the battery management system, right? Okay. Okay, Shivraj, is it clear? Sanjita, Sneha.
Yes, sir, clear.
Okay, let us study the BMS actual architect, right? So you have the various cells, right? The cell 1, 2, cell 2, cell 3, cell 4, cell 5, like you are having the various cells in the batteries, right? Which are connected in a pack. So the cells are connected in series and parallel combination to make the module, then the pack will happen, right? So this is how the configuration of the cells can be done, right? So here we are giving all the parameters, right? We are giving the temperature, we are giving the current, we are giving the voltage for the measuring instrument, right? We need to check what is the balancing of each cells, whether the cells has been charged properly, all the cells has been charged at the same percentage. If the cell 1 is charged for 50%, the cell 2 has to charge for 50%. Cell 3 also should be charged for the 50% only. So likewise, all the cells should have the proper charging, and also they should have the proper discharging also. So that is the reasons we need to make the battery management system. We have to measure the first parameter. First, these are the inputs, right? Actually, this is the battery. Okay. From this battery, we are what are the parameters we are taking? We are drawing the parameters of the that is cell voltage, cell temperature, and the current. All right. So this is actually we are taking the input from the batteries. Now from the batteries, these will be given to the measuring instrument where we need to have to check the each cell temperature, whether it is going the exceeding its nominal temperature, or whether it is trying to get the overcharge, whether it is trying to have the over voltage, or charges energy density in the cells. That is what we have to see. For the measurement purpose, we are taking the all these various parameters. This is actually the input, and these are the SOC, SOH, and thermal management, SOC, SOH. These are the actual output. So these are the output we are going to analyze, right? So from this data, this data can be given to the your bus controllers. All right. So this is actually this part. We can say this is actually the battery management system blocks. So where this is the input, right? We are going to see the inputs. We are taking the input from the for the current, voltage, as well as the temperature. These are the inputs which is given to the measuring instrument circuits, and output are the state of charge, state of health, and capability estimations, right? We have to estimate how much of what is the status of the batteries, each cells. We have to estimate how much of it is charged, whether it is charged for cell 1 charged for the 20%, cell 2 is charged for the 30%, cell 4 is charged for the 60%, right? So each cell has to be charged at the same percentage. Not, they should not have any variations. That is what you have to estimate the capabilities of the each cells. All right, and there should not have the runway. Runway nothing but the thermal runway. Thermal runway should not happen in the neighboring cells. All right, if the cell ones don't have any thermal runway, thermal runway, right? The cell 2 may have the thermal runway also. So this should not be happen. So that's why we have to monitor each and everything. Every minutes, every second you have to monitor. That's why we are introducing the battery management system. All right, to check all these various outputs, state of charge, how much of charge is left to drive the vehicles, right? And we have to check the each cell's the life cycle. That is the battery health condition you have to check. That is the state of health condition. And we have to check what is the temperature, whether the temperature is exceeding or not. In the yesterday's class sessions, we have seen the Excel sheets. The various Excel sheets has been analyzed to understand the thermal management. Every time the temperature was around 25 to 26, 25 to 26, 25 to 26, when it is fetching all the current and voltage data from the batteries. So that's why we have to see all these output parameters. We have to monitor all these output parameters for every minutes, every seconds you have to do it. So all right. So now you see what does the BMS will do? What is job of the BMS actually over here? The job of the BMS is to function of the BMS to save your cells. Each cells should not get damaged from the overcharging or over thermal runways, right? And we have to make the optimized charge controls, right? And we have to determine the find out how much of state of charge is there. So nothing but how much of charge is left. How much of charge is left to drive the vehicles, right? Whether it is left for 70%, the state of charge is 70%, then we can say the charge is can drive for another 200 miles or 300 miles like that. So, and also for the state of health determinations, right? We have to determine the health condition, that is the life cycle of the batteries, right? If it is giving 50% of the percentage of the SOH, right? It means that it may have another 300 means 150 cycles is already completed. Remaining 150 may be there for 50% of the 300 cycles, right? So that is how you have to determine. We have to determine from the right from the beginning to the end of the lives, right? And also we have to balance cell balancing, where you can observe the all the cell has to be balanced in the proper ways, right? During the charging conditions, right? So that is what we have to see how the BMS will do the jobs, right? And also if we don't make the production, we can see in these images the battery is gets overheated and also it is trying to explode, right? So operating of the batteries outside its very specified design limits with the inevitable leads to the failure of batteries, right? And performance of the characteristics of the batteries are limited to the maximum current, maximum voltage, and minimum voltage and maximum temperature and minimum temperature reading. So these are the characteristics. There should have the optimal range. Optimal range of the your minimum voltage and maximum voltage will be there. Minimum temperature and maximum temperature will be there. So these are the specified limits. Within this limit range only you have to operate your batteries, right? So for operating these parameters, right, we have to study the your battery management system, right? So this will help us in keeping the batteries to operate under all these limited safe operating regions, right? So that's why if you want to protect yourself, please go through the minimum values and the maximum values of your voltage, current, and the temperature. That is maximum current, minimum voltage, and maximum voltage, and maximum temperature and minimum temperature reading, which should be the specified limits, so that the battery can be protected. So if this exceeds the maximum values, so what will happen if the temperature exceeds? So this is actually in these images we can observe that there is a getting overheated or the due to rise in the temperature. So all right, so these are the reasons where it is going to make the lot of differences. So all right. So I hope the definitions of the BMS is clear. Is it clear, Shivraj? Sneha?
Yes, sir.
Okay, we'll study in depth one by one. Okay, we'll study in the depth. This is just an introduction. I'm just giving introduction to you, right? We'll understand with the various concepts. So, all right. So in this image, they are showing the it is 99% charge, right? The charge control. We have the charge controller. The major cause of the battery damage is to implementation of the improper charging techniques, right? That is what we have discussed in the previous sessions, right? There should have the depth of discharge and also the SOC charge. That is the depth of discharge should be there. So below the 20%, below the 30% only you have to go for the again recharging. So if you have 70% of SOC, please don't go for the chargings. So that is the proper improper way of charging techniques. Understood? So charge, we have to see the charging properly, when to charge and when not to charge, right? So once the battery is fully charged, the charging current has to be dissipated somehow. Alright, usually when we charge, no, usually the there is a dissipation of the current will be there when you connect to the loads. The result in the generation of heat and passes through the of which there are bad of for the batteries things will get overheated. If you charge the more and more, no, the battery will also get overheated. So due to the dissipations of the heat, we have the circuits in the BMS. We have the circuit in the BMS where we have the internal cells of the resistance also, right? So the resistance will try to deliver the power in terms of the heats. So that's why you should not go for the overheating of the charging of the batteries, right? To avoid this, the BMS is very, very important, right? To avoid this, BMS is very, very important, and it has to be utilized for monitoring all these various parameters, right? And it terminates the charging when the upper limit of the voltage is known, as terminated the voltage is reached. So that is what it will try to understand during the charging purpose, right? During charging purpose, if it is 100% charge, it will try to disconnect and it will bypass. There is a bypass circuit we have in the BMS, right? In this BMS circuits, we have the bypass, right? It will try to check the capability estimations, and also it will try to check the state of charge, and it will try to check the monitor of the health conditions, right? So it will try to check the cell balancing, whether all the cells are charged at the same percentage, cell 1 to cell 10, all the cells have been charged with the same percentage. It will try to monitor that also, and also it will try to monitor the estimation of the capabilities of the cells, each cells, right? It also monitor the state of charge and state of health, right? So that is what we are just thinking about here. To avoid this, the improper of the bad battery conditions, right, and the excess of heat, they have given the very best example to make us to understand. So once the battery is fully charged, the charging current has to be dissipated somehow, right? If it is 100% discharge, then there should have the dissipation, right? The result in the generation of heat and passes, both of which are the bad for the batteries, right? So you should not go for the excessive charge of more than the 100%, right? So to avoid this, we need to disconnect the batteries, right? We have to disconnect the batteries from the overcharging, right? So that's why it will try to terminate the charging with the upper limit of the voltage. Once the upper limit of the voltage is reached, for example, the cell has 4.2 volts, all right? So when this is the upper limit, and the lower limit may be of around 1.2 something like that, right? So this is the limit range. So if it is exceeding that limits, upper limit, then there should have the terminating the voltage is reached. That is what it has to give intimations to the users. The voltage is reached to the maximum levels. Then you have to disconnect your battery charging system, right? That's why we have to go for the BMS to be controlled for the rate of charge. So all right. So this is how the state of charge determination can be possible. So all right, you can see there is a one first battery is charged for 10%, other is charged for 50%, other is charged for 100%. All right. So if you say the each cells which can maybe contains of 4.2 volts, right? 4.2 volts or 3.5 volts. All right, we'll consider the voltage ratings, right? We will define what is the state of charge. To understand this, it is very simple, right? We have to understand the state of charge is very, very important concept here in our battery management systems, right? The state of charge is defined the available capacity of the batteries expressed as a percentage of actual or estimated rated capacity, right? So it is defines the how much of still the charge is left over, right, to actually drive the vehicles. So all right, the state of charge will defines the availability capacity, how much of capacity is remaining. So remaining energy, remaining charges in the batteries. In this, you can see there is a 50% is remaining in the picture number 2. In the first picture, there is a 10% is remaining. All right. In the third image, there is a 100% of fully charged. 100% it is remaining. So that is the state of charge, right? How much of charge is left over to drive the vehicles. So that we defines the state of charge. All right, so it is defined the availability of the capacities. How much of capacity is available? How much of energy is available? How much of charge is available in the batteries? So that could be expressed in terms of percentage, right? Percentage, that is actual and the rated capacities. We have to find the percentage of actual and the rated capacity, right? So we have given SOC percentage is equal to estimated capacity, right? For the estimated capacity is around, for example, if you take it is 10 Ah, right? If you take the 10 Ah, right, and removed capacity is 5 Ah, and estimated capacity is how much? It is 10 Ah. So what is the value of SOC then? It will comes to be around 50%, isn't it? Yes, sir. It will comes to be around 0.5, right? So that is actually the state of charge, right? Where the capacity can be reviewed with respect to this equation, that is we are going to integrate from the 0 to time period, that is in the 0 to t values with respect to the current, right? With respect to the change in the current with respect to the time. So I is the discharge current and it takes the time in hours. How much of current is being discharged? I is the current. How much of charge? How much of current is discharged in the specific time periods, right? So that is how the state of charge is determined. Okay, when you determine the state of health conditions, right? So that is the state of health condition, the ability of a cell to store the energy, right? Like source like a sink or a high current and the retains the charge over a extended period as a relative to its initial or the nominal capacities, right? You can see there is a power fade and the capacity fade in this graph, right? So the state of health condition, it is going to be decaying very gradually, right? The state of health will try to determine how much of current is left over with respect to its life cycles. All right. So for example, the current is over here around 40, 50 and 50 H, right? So we'll take in the y-axis. So we are going to take in the y-axis in terms of if we take in terms of ampere hours, right? In the x-axis we'll take the life cycles. All right. So if the temperature is around, if the capacity of the battery is around 50 H, 50 H at the initial stage of 0 cycles. So if the cycle is get increased, what will happen? From the 50 H, it will reduce to the 40 H if 100 cycle gets completed. Let us consider that it has only the 300 cycles. Sorry, 300 cycle of the life, right? At the 0th cycle, the battery capacity, that is the battery health, is very good. That is a 50 H. So when it is getting reduced, the cycle of 100 cycle is get increased, no? Then what will happen to the age? The age will also get reduced, right? It will determine the actual health conditions of the batteries during once the 100 cycle is reached. So again, when it is coming to the 200 cycles, what will happen? From 50 to 40 has been reached. Now 40 to it will go to 30 H. Here it would be the 30 H of the batteries, right? So again, when it is reached to the 300, almost it will go to the 0. There will be 0 H, means it will not able to capability to charge, or it is not able to capability to discharge. So that is what it will determine the health condition of the batteries. How much it can charge, how much it can discharge during the particular life cycles. All right. So that will determine the state of health conditions. All right. So this state of health condition is also very, very important to understandable, which can be understood in a very easier way, right? If you see the power fade, the loss of the cell power due to an increase in the cell temperature. When the power fade will occurs when there is a rise in the impedance, right? When there is a rise in the impedance, also there is a try to loses the cell power. If the impedance of the cell get increases due to the aging factors, the power fade will also get increases. So that's why you have to check about the power. It will not be able to deliver the power actual what it was delivering earlier, right? So that is what the reason, the power fade. So all right. So when you talk about the capacity fade, the gradually loss of capacity of the secondary batteries. So with the cycling is known as the capacity fade. So capacity fade will also occurs. It will tell how much of remaining life it can give. So how much of life it can try to give. That will tell us about the state of health conditions. All right. So in this diagram, you can see there is a balancing of the cells. Right. In the above picture, you can see there are multi cells are connected, right, in the battery pack, and then it is you get module. Then all the cells are charged at a time, right, with the same percentage. In the second figure, you can see some cells are charged and some cells are not able to charge. Correct. So that is one reason, right? Here also, in case of state of health also, the battery age will also matter a lot. It tells how the health of the battery is when it is a new earlier, when it was new, and what was the health. When it is old, and what is the health. That is what it will define. State of health will define what is the health, actual health. All right. When you bought for the first time, what was health. So after usage of 2 years, it will determine what is the health conditions. And everything will depends upon the life cycles. Everything will depends upon the age, right? That will determine the state of health also, right? So state of health will define the how much of actual current capacities and to the nominal capacities, correct? It will determine the current capacities of the batteries to the nominal capacities. When you multiply with 100, you will get the state of health conditions. So, all right. So that is the state of health of the power can be determined the maximum current, right? That is the maximum power. The current maximum power to the nominal power, right? That is a nominal maximum power. It will try to determine the actual state of health of the powers, right? For example, if you take a new batteries of 100% of SOH, right? Usually when it is having the 70 to 80%, right? After the usage of 1 or 2 years, then you can say the state of health is 70% because of the life cycle. Life cycle it will keep on reduces. Okay, life cycle will keep on reduces. Okay. Mamta, is it clear? Am I audible?
Yes, sir.
Okay, in this you can see there is a balancing of the cells, right? So every time we have to keep on see the how the cells is being charged and also being discharged. The first image will tells about the all the cells are charged at the same percentage, but in the second image it tells about the cells has been charged for the different time with the taking the much time to charge and taking the very more time to charge or less time to charge, right? So this is let us see how the cell balancing can be done in the each cells as well as with the module then the pack and the batteries. So all right. So these are the various things, right? So if you see the multi-cell batteries change, a small difference between the cells due to the production tolerance and or the operating condition tends to be magnified each charge discharge cycles. So weaker cells becomes a overstress during the charging, causing them to become a even weaker. So because of the failure of the cells, if the one cell get failed due to the its chemical compositions are due to the cracking in the electrodes, so what will happen? It will not able to charge. So that is the reason why these cells have the different the percentage of chargings. So due to the aging cells, due to the age also, due to the cracking in the electrodes or due to the aging also. So due to these are the various reasons why the cells are not having the equal charging. So all right. So these are the various reasons. So weaker cell also will have the overstress. If you don't, you cannot apply for the overstress to these cells because it loses its already charging capabilities. It will not charge as earlier it was charged due to the failure in the electrodes, right? Due to failure in the internal resistance, right? So these are the various reasons. That is what you have to think about the batteries. Each cells we have to study the battery cells so that we can. That is what we are going to learn the battery management system. In the battery management system, we are going to check each cell voltage. Why the cell is not charging? What is the reason behind that? Right. Right. So that is the reason. So if you see the failure, if there is a cause of fail, the causing the premature of the failure of the batteries, right? If the cell is become weaker and weaker and weaker, what will happen? That is the reason to fail the batteries, right? Because of the failure in the electrodes, it is not able to charge properly. It is not able to discharge properly, right? And also there is a chances of premature of the failure of the batteries. So then you have to replace the used batteries. All right. If you see the cell balancing is a way of compensating the for weaker cells by equalizing the charge on all the cells in the chain and thus exceeding the battery life. All right. We'll see how to make the cell balancing. Right. We have to compensate for the weaker cells by equalizing the charge on the all the cells. So let us how we can do this. All right. So let us see the what is the meaning of state of charge. Actually, we have to understand the state of charge, state of health, and the state of monitor of the cells. Okay, we'll see what is the state of charge. All right. So when you see there's a 80% is charged, right? In this display, you can see there is a 80% has been charged, right? Written as electric vehicle or the or battery pack. The percentage does not come from the simple measurements, right? It is saying that there is a 80% is charged, right? That the 80% is. What does it mean actually? Right, we have decided we cannot say with a very in a without making any calculations, right? Without knowing any deeper concept, you cannot say it is 80% charge. Now you can we have to study the cells modules of the cell structure, the cells how the cells is going to behave during the charging and discharging, right? Then only we can decide the what is the value of the charging of the batteries, right? So we should have to know the lot of deeper concept to understand the state of charge, right? So if 80% is charged, what does it mean actually? The vehicle of the batteries pack. So that percentage does not come from the actual measurement. So let us see how the measurement will come, and to understand this concept, we have to study the state of charge. All right, I'll tell you the state of charge in a very easier way, right? So when you see the 80% is charge, which is written on the electric vehicle. So what does it mean actually? The percentage also will not come from, actually we have to go through the deeper concept to the state of charge. Let us see what is state of charge. So state of charge will tells how much of energy left inside the battery compared to its total capacity. All right. So now let us see what is the state of charge. For example, if the battery is the battery capacity, right? We need to see the capacity of the batteries and the total capacity. The capacity remaining capacity of the batteries to the total capacity. When you multiply with 100, you will get the state of charge. All right. So the state of charge will tell us about the how much of energy is left inside the battery as compared to the total capacity. So now if you take the total capacity of 100 Ah, so all right, so 100 Ah is the total capacity, right? The formula will be given like this: the remaining capacity to the total capacity. Okay, the remaining capacity to the total capacity, when you multiply with 100, it will give the actual value of the state of charge. All right, so now let us determine how to identify this. Okay, so can anybody tell me how to determine this? Brush me. Sneha. Okay. Okay, we'll see. The state of charge will tell us about the how much of energy is left to inside the batteries, right? For example, if the state of charge is right, if we want to say state of charge is around 80%, right? How we can make the calculations for the state of charge? We have to determine the actual how much the charge is left, right? How much of charge is left inside the batteries when you compare with the actual total capacity. Now let us see the what is the total capacity of the batteries. It may be of 50 H. For example, it is a 50 H battery, right? So if the battery is reading is 50 H, right? So then you can see the remaining capacities. That is in the numerator, as I told, there should be the remaining capacity to the actual to the total capacity. So what is the remaining capacities? You said that it is a around 70%, right? So if it is around of 70% means you can calculate very easily, right? If the battery H is 100 H, for example, total capacity is 100 H. How much of energy left? The energy left will be 70 H, correct? So 70 H divided by 100 H into 100, so it will give you 70%. So this is how we have to make the calculations, right? The state of charge means simply how much of energy is left inside the battery first. We'll compare to its total capacity. So energy left is around 70 H. Okay. Next 70 H will able to drive the vehicles. That is 70% of energy is remaining. Actual from the actual total capacity from the batteries. Okay. The total capacity is around 100 H. What is the remaining energy? That is the 70. So 70 H divided by 100 H into 100. So obviously it will give the in the numerator denominator is 70 H by 80 H. Sorry, 70 H by divided by 100 H. H will get cancelled. When you multiply with 100, it will give the 70% of the state of charge. All right. So this is how you have to calculate. Understood? So is it clear? So
Yes,
is it
sir.
clear, Mamta?
Yes, sir.
You can put the formulas, you can check, you can check the formula, right? So you can understand very clearly that how much of total capacity, right? Now total capacity is, take it as a denominator. The battery rating is 100 Ah. Okay, all right. You have bought a new batteries. The rating of the battery is 100 Ah. So that is the total capacity. That is the actual capacity of the batteries. Okay. Now the remaining capacities. When you talk about the remaining capacity of the batteries, right? The remaining may be of 70%. After usage, we are having only the 70%, the 70 Ah. That is 70 Ah is the remaining energy which is left in the battery. So 70 Ah divided by 100 Ah. Okay, multiply with 100. So it will give the 70% of the state of charge. That is how you have to calculate the remaining charges in the batteries. Means that there is a 70 Ah is left out of 100 Ah. Okay, when you multiply with 100, it will give the 70% of the state of charge. Okay, this is the formula. Okay, you can please take a screenshot of this. From this formula, you can identify very easily, right? That is the state of charge simply means how much of energy left inside the battery compared to its total capacity, right? So in the Q total, okay, in the Q total, what I will do, I'll give the 100 each. I bought the battery for 100 each, okay, 100 ampere hour. My battery rating is 100 ampere hour. I'll put it in the denominator. So the Q total is equal to what? 100 each. The Q remaining, right, out of 100 Ah, how much of charges are remaining once you discharge, right? The 70 Ah is remaining. Okay, out of 100 Ah, there is a 70 Ah is remaining. So I will keep Q remaining as a 70 Ah to the total. What is the total capacity of the batteries newly bought? It is 100 Ah. So 70 Ah divided by 100 Ah, when you multiply with 100, it will give the 70% of state of charge. Now I hope it is clear to you.
Yes, sir.
Correct. ಸೊ ಆ್ಯಕ್ಚುಲಿ ಬ್ಯಾಟ್ರಿ ಎಷ್ಟಿದೆ ನಿಮಗೆ 100 ತಗೊಂಡು ಬಂದಿರ್ತೀರ ಹೊಸ ಬ್ಯಾಟ್ರಿ. ಓಕೆ, ಆಲ್ರೆಡಿ ನೀವೇನು ಮಾಡಿದ್ದೀರಾ, 100 H ಅಲ್ಲಿ 30% ಆಲ್ರೆಡಿ ಯೂಸೇಜ್ ಮಾಡಿಬಿಟ್ಟಿದ್ದೀರಾ. 30%ನ ಏನು ಮಾಡಿದ್ದೀರಾ, ಯು ಗಾನ್ ಫಾರ್ ಅರೌಂಡ್ 30 ಕಿಲೋಮೀಟರ್ಸ್. 30 ಕಿಲೋಮೀಟರ್ ರನ್ ಆಗಿಬಿಟ್ಟಿದೆ ವೆಹಿಕಲ್. ಓಕೆ, ನಾವು ಬ್ಯಾಟ್ರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮಿಂದ ಬ್ಯಾಟ್ರಿ ಹೇಳಬೇಕು ನಮಗೆ, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮ್ಯಾನೇಜ್ ದ ಬ್ಯಾಟ್ರಿ ಬಿಕಾಸ್ ದಟ್ಸ್ ವೈ ಇಂಪ್ಲಿಮೆಂಟಿಂಗ್ ದ ಬ್ಯಾಟ್ರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್. ಇಟ್ ವಿಲ್ ಟೆಲ್ ವಾಟ್ ಇಸ್ ದ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ದ ಬ್ಲಾಕ್ಸ್ ಐ ಹ್ಯಾವ್ ಶೋನ್ ಇನ್ ದ ವೆರಿ ಅರ್ಲಿಯರ್. ಎಸ್ ಆರ್ ಹಿಯರ್ ಐ ವಾಂಟ್ ಟು ಸಿ ದ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್. ಸೊ ದಿಸ್ ಸೆಲ್ ಬ್ಯಾಲೆನ್ಸಿಂಗ್, ಪ್ರತಿ ಒಂದು ಸೆಲ್ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಕೂಡ ಚೆಕ್ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. ಈಚ್ ಪ್ರತಿ ಸೆಲ್ಸ್ ಇಟ್ ವಿಲ್ ಟ್ರೈಂಗ್ ಟು ಮಾನಿಟರ್ ಎಷ್ಟು ಇನ್ನು ಯೂಸೇಜ್ ಆಗಿದೆ, ಎಷ್ಟಾಗಿದೆ, ಇನ್ನೆಷ್ಟು ಉಳ್ಕೊಂಡಿದೆ ಚಾರ್ಜ್ ಒಳಗಡೆ, ಸೆಲ್ ಒಳಗಡೆ. ಸೊ ದಟ್ ವಿಲ್ ಡಿಸೈಡ್ ದ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್. ದಿಸ್ ಇಸ್ ದ ಔಟ್ಪುಟ್ ಆ್ಯಕ್ಚುಲಿ. ಸೊ ದೀಸ್ ಆರ್ ದ ಇನ್ಪುಟ್. ನೋಡಿ ನಾವೇನು ಮಾಡ್ತಿದ್ದೀವಿ, ಕರೆಂಟ್ ವೋಲ್ಟೇಜ್ ಪ್ಯಾರಾಮೀಟರ್ ತೊಗೊತಾ ಇದೀವಿ, right? We are taking the current. So in this current, how much of energy is left over, right? So that will gives the output in the state of charge. All right. So that is what you have to determine the your battery state of charge. Okay, that is the state of charge. Simply means how much of energy is left inside a battery. In ಎಷ್ಟು ಉಳ್ಕೊಂಡಿದೆ ಅದರಲ್ಲಿ, ಎಷ್ಟು ಚಾರ್ಜಸ್ ಉಳ್ಕೊಂಡಿದೆ. ಸೊ ದಟ್ 70 H ಇದೆ ಅಂದರೆ ಆಕ್ಚುಲ್ ಬ್ಯಾಟ್ರಿ ರೇಟಿಂಗ್ಸ್ ಇರೋದು 100 H. ಓಕೆ, 70 H ಡಿವೈಡೆಡ್ ಬೈ 100 H ಇಂಟು 100 ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನಿಮಗೆ, ಪರ್ಸೆಂಟೇಜಲ್ಲಿ 70 ಕೊಡುತ್ತೆ ಅದು. ಎಸ್ ಆರ್ ನಾಟ್? ಅಂದರೆ ವಿ ಹ್ಯಾವ್ ಓನ್ಲಿ ದ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ 70%. So 70% again you can go for the 70 kilometers. Means I'm just telling about the approximation of the kilometers, right? So if the 100 H is there and the 100 H is there, it will traveling for the 100% of the charge. So correct. So ಅದೇ ಥರ ಇವಾಗ 30% ಆಲ್ರೆಡಿ ಏನಾಗಿದೆ, ಯೂಸೇಜ್ ಆಗಿಬಿಟ್ಟಿದೆ. ಇನ್ ರಿಮೈನಿಂಗ್ ಉಳ್ಕೊಂಡಿರೋದು ಎಷ್ಟಿದೆ, ವಿ ಹ್ಯಾವ್ ಓನ್ಲಿ ದ 70%. So 70% is the remaining to the actual capacity of the battery is 100 H. So 70 H by 100 H multiplied with 100, it will give the 70% of the charge. That is the state of charge. That is the output which is taken from the battery management system. Battery management system is doing this job. Adu ಮಾಡ್ತಾ ಇದೆ because we are taking the parameter, we are sensing the parameter from the voltage and current from the each cells and the temperature also at all the times. That's why we are getting this state of charge. That is the output from the BMS. Okay, so what is the importance of SOC? SOC is nothing but is the core parameters, right, of any battery management system. So without SOC's battery control system would be like a operating blinds. So BMS ಮಾಡಲಿಲ್ಲ ಅಂದರೆ ನಿಮಗೆ ಇನ್ನೆಷ್ಟು ಚಾರ್ಜ್ ಉಳಿತೋ, right? We cannot make the predictions, right? We cannot make the prediction. Suppose if the vehicle is running the more and more faster, right? More and more faster, or due to the thermal runway. If sometimes the thermal runway ಆದರೂ ಕೂಡ ಏನಾಗುತ್ತೆ, the battery will not have under the our controls. All right. So due to the excess of the loads in the vehicles, right? So battery will try to draw the more current for the motors. Okay, so there are many reasons to have the uncontrolling of the batteries, right? So that's why we have to study the battery management system so that the SOC can be monitored properly, right? State of charge can be monitored properly because SOC will tells to analyze the each cells. It will understand the each cells. It will study the each cells parameter, right? That's why we are given in the very most basic things. It is trying to manage the each cell parameters, voltage, current, and temperature. Everything it is going to monitor from each cells. Every time it will give the input. Just we are feeding a sensor to the each cells. So sensor will try to sense voltage. We have the voltage sensor, we have the current sensor, we have the temperature sensor. All the sensor will try to collect its data. Every time it will collect its data and it will give to the controlling units, right? So where we are going getting the output from the BMS. All right, if you don't do this, no, you cannot go for blindly to see the what is the battery life. We cannot have the battery life easily, right? To analyze the battery life, to see the conditions of the batteries, should go for the BMS, right? So BMS is also very important to we need to check the what is the life of the batteries and what is the temperature in the batteries, what is the current in the batteries, right? And how much it is reliable for the usage, right? So that is a direct measurement, right? In this we have in this diagram I have shown the measurement of we have shown the measurement of cell balancing, right? We are going to measure the all these parameters, current, voltage, and temperature. All right. So here also we have to see how we are going to measure. That is one is the direct measurements, right? Other is the Coulomb counting methods.
Sir,
What is the Just tell me.
sir, sir, slides visible ಇಲ್ಲ sir.
1 minute, I'll check. Is it visible now?
Yes sir. Yes sir.
Okay. So we are just discussing about the that we are going to monitor the battery, right? What are different types of measuring techniques we have? So in this diagram, I have shown that we are going to measure the various parameters, right? So okay. So in this diagram, you can see we are going to monitor the various parameters. What are the various parameters here? Temperature, right? We are monitoring the current. We are monitoring the voltage. So these are the parameters are required for the measurement purpose. From the each cells, we are going to fit the sensors over here. We are fitting the thermal sensor. We are fitting the current sensor. We are fitting the voltage sensor. So all the sensors will try to sense the parameter from the each cells, and it will given to the controlling units, right, where it is going to measure these values, right? Then it will give the output for the state of charge and state of health. So that is what are the different measuring instrument, what are the different measuring techniques we have. That is what we have to learn here. Okay, one is the direct methods. So in the direct method, you can see the battery voltage and currents are directly measured to estimate the state of charge. However, the approach is not very reliable, right? Because the voltage keeps changing with the temperature and the load conditions, right? Because of only one parameter, you cannot decide the battery life. You cannot decide the battery conditions. All right. So that is the reasons. Okay. Hello. కొంచెం ఆన్సర్ మీకు ఇంటూరిన్ ఆన్సర్ ನನ್ನ ಫೋನ್ ಕರಂಕಮ್ಮ మా క్లాసెన్స్ మా ఫోన్ కనుక మా క్లాసెన్స్ ఉన్నాను రెడీగా కనుక आम्ही आज सरी मा तू वन फोन करन का समझो ना सरी का Okay. So what are the measuring techniques we have? One is the direct method, right? Am I audible?
Yes, sir.
One minute, somebody has entered in the. Okay, no problem. So we have to measure the various parameter, right? And based on that, we can make the predictions of the batteries, right? So here in this method, the battery voltage and current are directly measured to estimate the SOC. It is not reliable. If you measure the voltage and current, right, it will give the actual power of the batteries, right? But we are not measuring the one more parameter. From these two parameters, you cannot decide the state of charge. We cannot decide the state of health of the batteries. It is not possible, right? So that's why this method is not very suitable for the calculation purpose, right? So because the voltage keeps changing with the temperature, right? If the temperature exceeds and the load, because of the load conditions, so what will happen? We will try to draw the heavy current from the batteries. So we have to consider the temperature also. If you consider the temperature, then only your calculation will become in a proper way. So this approach is not very in the correct methods to make the measurement purpose, right? So direct method is not a suitable for to measure the battery health conditions or the battery charging conditions. All right. So because of you are just taking the two parameters, that is the voltage and the current, right? Which is are directly measured to estimate the state of charge. So this is not possible, right? Consider along with the temperature, right? Though because the voltage also will keep on changing, because the voltage will not remain same. If you have that 4.2 volts, no, it may can get reduced to the 2.2 volts, right? So because of the ampere hours, because of the ampere, what will happen? It will keep on decaying. So it will start decaying with your as the life cycle get also increases, right? So when you say the state of charge is 50%, right? When you say that there is a 50% of SOC. So we been observed that if we take the in the x-axis and the y-axis, right? In the x-axis, if you take the ampere hour, you can just note down in the x-axis if you take the ampere hours, okay. In the y-axis, you can take the loads. All right. So based on the your voltage condition, for example, the voltage on the y-axis, let us consider the voltage and the current. Okay, we'll just understand this direct method concept, right? In the y-axis, you take the voltage. In the x-axis, you take the current. Okay, current in terms of ampere hour. In the y-axis, it is a voltage only. The cell voltage is around 3.5 volts. Okay, that is the maximum value, and the minimum value is be around of 1.2 volts. Okay, so if you plot the graph in the very deep, like a deeper way, like climbing the hills, right? As a climbing the hills. All right. So what will happen if the cell voltage is around 3.5 volts, right? If the current is trying to discharge, if the current is trying to get more and more, right? When it is coming at the midpoint of this midpoint of the cells, so then you can say there is a 50% of discharge, 50% of SOC, and also during that time the voltage is also get reduced gradually. Okay, the voltage will also reduces when it is coming to the 50%. So because of this, there is a changing in the, there is a voltage will keeps changing. That is what voltage will not remain same. Yes or not? With the temperature, if you take the temperature, no, with respect to the temperature, voltage will not remain same. The voltage may come from the 3.5 volts to 1.2 volts due to the loading conditions. All right. So that is one reasons why we are not following the this direct methods. Okay. So this is the reasons of the failure of these methods. Next, we have the Coulomb counting methods. Okay, so Coulomb counting methods will tell us about the how much of charges are left over, right? So that is, it will tell us about the most practical and the method for estimating the SOC. See, SOC can be done in various methods, right? We have the Kalman filter methods. We have adaptive Kalman filters. We have, right? Coulomb counting methods are there. There are many methods to determine the SOC, right? Not only this method, we have the various methods. So one method, the direct measurement method was failed because of voltage is keep on changing, and when voltage is also depending upon the temperature and the load conditions. So that's why this method is not very suitable to go for the calculations. So all right. So when you talk about the Coulomb counting methods, right? When you talk about the Coulomb counting methods, this is one of the most common and practical method for estimation the state of charge, right? So in this method, the current flowing through the battery is integrated over the time to calculate how much of charge has been discharged or charged. All right. So you can see in the Coulomb counting methods, if you see there is a in the x-axis, if you take in the x-axis, if we plot with respect to the time, okay. So in the y-axis, if you take the current, so you can just note down in the y-axis for the Coulomb counting methods, in the y-axis you take the current I, okay. In the x-axis you take the time, okay. So with respect to the time and the current, right? So that is what EH, that is EH we are taking ampere hour, right? Ampere hour countings. So how much of current is left, how much of charge is left with respect to the time. So in this batteries you can see how much of charges are left, how much of charges are left in the battery conditions. That is, it is going to count how much of coulomb of charge, how much of coulomb of charge is left in the battery. It will try to count, this method will try to count the how much of charge is left in this batteries, okay. If you take in the y-axis, if you draw current in the y-axis, draw the time in the x-axis, okay. So you if you draw the plot of y-axis versus the x-axis, current versus the time, okay. If you come the deeper like curvy shapes, if you come in the curvy shape like this, no, so what will happen, that will leads to the Coulomb counting methods, how much of charges are left over for the driving the vehicles, right? So that is what he had to go through the calculations, right? There is a specific formula for this to finding out the Coulomb counting methods, right? So that will tells about in this method the current flowing through the battery is integrated over a time. How much of battery is being charged, how much of coulomb of charge is there with respect to the time. So it will calculate how much of charge has been left or discharged. So that is how the Coulomb counting methods. So we have a lot of calculations to find out the Coulomb counting methods, right? We have the SOC, we have the various formulas, right? Direct method has one formulas, right? So that is the Q remaining divided by Q capacity, right, into 100. So Coulomb counting methods will calculate over the time. We have to integrate. We have to take the integrations of SOC, previous SOC with the current SOC. We have to take the integration. SOC of T is equal to SOC of naught. We have to take minus integrating from T naught to T0 to T1, right? Over the I of T divided by T. That is what you have to make the calculations for the Coulomb counting method. It will decide, it will check how much of charge is left over in the batteries, right? So this is the one of the method. This method is also failed to calculate the actual the capacity of the batteries, right? It will check only the state of charge. The Coulomb counting method will tells about the how much of charge is left actually, how much of charge is left in the batteries, okay. So that is what you can see, there is a charges, how much of charges are remaining over there, okay. So if you plot the graph with in the y-axis, that is the current, and the x-axis you plot in the time, right, with respect to the time, for the specific time, if you draw the graph like this in the zigzag way, right, like this, if you draw in the graph like zigzag ways, it will try to see how much of charge is left with a specific time, okay. It may be during charging or it may be during discharging. So discharging, charging, I'm just talking about the vehicle maybe in the running condition. If you have the solar panel on the rooftop of your vehicles, right, during the regenerative braking, the battery may charge, right. If you don't have the solar panel, it will discharge. So based on that, the implementations, we can go for the Coulomb counting methods. We can make the predictions, right, during the charging and discharging conditions. How much of charge is left and how much of the charge has been discharged from the batteries. So all right. So Coulomb counting method is the most common practical method for estimating the state of charge, right? So in this method, the current flowing through the battery is integrated. You can see SOC of T. So SOC of T, what you tell actually, this is the actual time, the present time, right? In the present time, I want to check what is the value of SOC, state of charge. ಈಗ ಎಷ್ಟು ಚಾರ್ಜ್ ಉಳ್ಕೊಂಡಿದೆ ನನಗೆ ಇವಾಗ ಬೇಕು at exactly this time I want to find out if I'm running for the vehicle from 1 hour to 1 p.m. to 3 p.m. All right, I'm in the mid of 1 hour 45 minutes, okay, while driving the vehicle, right? Then I'll calculate, I want to see the state of charge. State of charge ಎಷ್ಟಿದೆ ಅಂತ ನಾನು ನೋಡಬೇಕು ಇವಾಗ, okay. So the SOC of the initial SOC ಎಷ್ಟಿತ್ತು, it may be of you have calculated that is the Q remaining divided by Q capacity, ಆ ವ್ಯಾಲ್ಯೂ ಬೇಕಾಗುತ್ತೆ 70% ಇದೆ ಅನ್ಕೊಳ್ಳಿ, right? It is maybe around of 50 or 70%. So minus of that is 1 over, we have to calculate 1 over the See, means integrating from 0 to t of with respect to the current of t. So this is how we have to calculate the with respect to the with respect to the current and the time. This is how you have to calculate ಎಷ್ಟು ಕರೆಂಟ್ ಉಳ್ಕೊಂಡಿದೆ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ ನಮಗೆ ಕೂಲಿಂಗ್ ಕೌಂಟಿಂಗ್ ಮೆಥಡ್ ಅಲ್ಲಿ how much of current is left out. That is, this is the most and common practical method, but this method is also failed for the because of various reasons, right? Again, we have the different method. We have the Kalman filter methods, right? So in this method, it will try to current which is flowing through the batteries is integrated over a time to calculate how much of charge has been charged or discharged during the specific time. It will tell us ಎಷ್ಟು ಕರೆಂಟ್ ಉಳ್ಕೊಂಡಿದೆ, ಎಷ್ಟು ಬ್ಯಾಟ್ರಿಯಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಉಳ್ಕೊಂಡಿದೆ ಅಥವಾ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿದೆ ಅನ್ನೋದು ಎಕ್ಸಾಕ್ಟ್ ಸ್ಪೆಸಿಫಿಕ್ ಟೈಮಲ್ಲಿ ಹೇಳುತ್ತದೆ. That is how the cooling counting method will tells us. Okay, so that is you are running your batteries from 1 pm to 4 pm, right? Exact ಆಗಿ 2 pm ಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳುತ್ತೆ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಉಳ್ಕೊಂಡಿದೆ ಅಂತ ಹೇಳುತ್ತೆ. So that is how you have to plot the graph of current in the x-axis, in the y-axis, and time in the x-axis. Okay, based on that you can identify the how much of charge is left. All right, so next we have the open circuit voltage. This is another methods. The battery is kept at the rest for some times. Okay, and this it is the open circuit voltage is measured based on this voltage. The SOC is estimated using the battery voltage. So battery voltage ಮೇಲೆ ನಾವೇನು ಮಾಡೋದು, open circuit ಅಲ್ಲಿ ಎಷ್ಟು ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ವೋಲ್ಟೇಜ್ ವಿಲ್ ಬಿ ಗಿವ್ ಅರೌಂಡ್ ಬ್ಯಾಟ್ರಿ ಸೆಲ್ಸ್ ಎಷ್ಟು ಇರುತ್ತೆ ಅಷ್ಟು ವೋಲ್ಟೇಜ್ ಕೊಡುತ್ತದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ಇಸ್ 3.5 volts, it is the open circuit as a 3.5 full voltage it will give, right? But you are not connecting to the any loads, so during the time also you can calculate the SOC. SOC calculation is very easier in the different methods, right? But in open circuit voltage only we are from the open circuit only without connecting the loads, right? When the battery is in the rest conditions, right, then the open circuit voltage can be measured very easily, which is based on the SOC can be calculated. Voltage ಮೇಲೆ ನಾವು SOC ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಉಳ್ಕೊಂಡಿದೆ ಬ್ಯಾಟ್ರಿಯಲ್ಲಿ, ಇಫ್ ಇಟ್ ಇಸ್ ಚಾರ್ಜ್ ಫಾರ್ 3.5 volts, ಇಟ್ ಈಸ್ ಬೀನ್ ಅರೌಂಡ್ 1.2 volts ಇದೆ ಅಂದರೆ ಅದ್ರ ಮೇಲೆ ಕೂಡ ನಾವೇನು ಮಾಡ್ಬೋದು, ವಿ ಕ್ಯಾನ್ ಡಿಸೈಡ್ ದ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ ಕ್ಯಾನ್ ಬಿ ಎಸ್ಟಿಮೇಟೆಡ್ ಇನ್ ದ ಬ್ಯಾಟ್ರಿ ವೋಲ್ಟೇಜ್, ರೈಟ್? This is another methods, right? The Kalman filter method is another methods. So this is very drastic methods, right? It is more advanced in mathematical modeling methods, right? So this method will use the actually the combining with the Coulomb counting and the open circuit voltage method. So that's why the Kalman filter method is more popular for the finding the state of charge, right? The Kalman filter has been introduced when these methods are failed, Coulomb counting methods and open circuit voltage failed. They have recombined, both the methods has been integrated, right? And they are finding the minimum errors. What are the errors? That is, we are going to find out in the for example cell temperature, it may be of your battery of the chemistries, and also it may because of the voltage, why voltage is getting degraded very slowly. All right, so this method will analyze in a very simpler way and will try to remove all these errors, right? So Kalman filter is a continuously updating the and correct the SOC estimation in a real time, making it highly accurate, right? It will tell about the how the batteries will be charged and how the batteries will be discharged, right? It will try to reduce the errors. Okay, this method is very simpler, right? So this method is a combination of both the OCV as well as the CC, that is the cooling counting methods, right? Kalman filter, we have the adaptive Kalman filter also, which is more advanced than this method. So this is completely a mathematical modeling, right? It will decide the modeling of the your batteries, right? It will tells about the try to remove all the kinds of the errors. It will decide the SOC, right, in the real time, and also making it very high accurate, right? Then we have the currently have the machine learning based, right? So in this we are going to use the artificial intelligence, right? We have to model, we have to train the data, right? It may be with the help of the cognitive learning also, right? So neural network, we can see there is a, in this diagram you can see there is a small of neurons, okay? In the brain system we have the very small of neurons, right? So each neurons, it has to, we are going to analyze the various parameters, right? What are the various parameters? That is voltage, current and temperature. These are the historical data, right? That is the past data. Then predict the future data that you have to predict. All right, so that is what in the previous sessions I told all the parameters, the voltage and current and temperature, which was shown in the earlier sessions. So that is because of the machine learning, right? In yesterday's sessions I told how the machine learning will work. Okay, you have to train the data first, take the data from the model, right, and make them to analyze, right, with the help of the neural network or with the help of the cognitive learning. Train the data. Okay, you have to train the data by learning the make the system, make the machines to learn unsupervised learning. Okay, it has to train the data. Once you train the data, it will try to develop the models. Entire models it will train. It will try to analyze the predictions. It will happen, right? The future prediction will also happen. What is the condition of the batteries? It will tell, and what is the temperature? It will tell, and what is the voltage? It will tell, and what is the degradations? Everything it will try to monitor. It will remove all the errors. It will make the actual predictions. So this is more advanced. Machine learning is more advanced as compared with the Kalman filter and adaptive Kalman filters as well as the machine learning. Okay. So these are the various methods. All right. So is it clear? Mamta, Rashmi, Sneha.
Yes, sir.
Yes, sir.
Okay, one of the method has been I've been worked on these methods, right? The adaptive Kalman filters. I've just removed a lot of error. I can show you the real-time data by using the mathematical modeling. Okay. I'll present that paper to you. So is it visible?
Yes, sir.
Okay, this is the one paper where I've been published in the Q2 journals recently in the year 2025, in the last year of September. All right, I use the adaptive Kalman filters. All right, we are using adaptive Kalman filter for the accurate state of charge estimation for the electric vehicles under the various operating conditions. So this was a title which was made by me. This is one of the paper which was published in the earlier in my name, right? Right. So currently we have working on the same paper with the machine learning. All right. So in this you can see I've been given the state of charge equation, right? SOC, right? So SOT, what it will tell? It will tells the remaining amount of batteries, right? The SOC tells about the remaining amount of batteries capacities that can be drive by batteries, right? That can drive the vehicles through the connected system with respect to the fully charged capacities. But SOC ಏನು ಹೇಳುತ್ತೆ actual Q value ಎಷ್ಟು ಇರುತ್ತೆ to the total value of the Q. That is Q remaining to the Q total. Multiply with 100 will give the SOC. SOC with open circuit voltage relationship. This is the relationship with the state of charge with open circuit voltage relationship. All right. So that's why we can say if the initial value of SOC is known, right? If SOC is known is 70%, okay. The instantaneous SOC of battery can be determined. ಆ ಟೈಮಲ್ಲಿ ನಿಮಗೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಎಷ್ಟು ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ ಉಳ್ಕೊಂಡಿದೆ ಅನ್ನೋದು ಹೇಳುತ್ತೆ. Kalman filter ಹೇಳೋದೇ ಇದು. The Kalman filter will tells about the how much of state of charge it is remaining, yes or no. So in this right, so it will update the correct the SOC estimation in the real time, making it high accurate. That is what it will tell the Kalman filter methods. Yes or no. The Kalman filter methods will tell it is a mathematical model, advanced mathematical model approach that combines data from the Coulomb counting methods and SOC, right, and methods to minimizing the errors. And also the Kalman filter will try to predict the data, right? It will update your data and it will correct the data. It will check the actual estimation that at the specific time. At the specific time in the real time ಎಷ್ಟು ಉಳ್ಕೊಂಡಿದೆ ಅಂತ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಹೇಳುತ್ತದೆ. That's why it is very highly accurate, right? So that's why we have been I made a lot of research on this, right? So that is what the initial SOC is known. The instantaneous of SOC can be determined very easily by the Coulomb counting methods, right? By the Coulomb counting method also you can do, from the Kalman filter method also you can do it, right? So this is SOC. It is the SOC, actually this is your SOC of T, right? This is the SOC of T. This is the initial, right? SOC is the initial, right? You can see the SOC is the initial, correct? SOC is the initial, right? What is the SOT? SOT is at that instant of time. That instant of time I want to have how much of the charges is being left, right? Minus of integrating from T naught initial time to the final time, right? So we are taking the current. That is the current with respect to the QB. All right. So QB is the battery capacity. All right. It is 100 Ah or 50 Ah, whatever it may be. So based on this, you can find out the battery total capacity of QB, quantifies the amount of charge that can be removed from the batteries, right? When it is fully charged condition at the fully discharged conditions. So that is what this is the SOC will works out with a mathematical modeling, right? So that's why we have to calculate the remaining SOC. All right. and I'll show the what is the errors we have been done. All right. So in this, with respect to the various temperature, right? With respect to the various temperature, I use the final method, that is error adaptive Kalman filter method, right? So for 20 temperature of degree centigrade, it is around 2.5, right? Then it has been reduced to 1.20. All right. At the temperature of at the temperature of 25 degrees centigrade, right? This is 0 degree temperature. This is 40 degree temperature, right? You can see there are the different values, and the values has been reduced to errors has been removed. You can see the error because that's why it is a error adaptive Kalman filter methods, right? We have been optimized. The cells has been optimized to the actual values. All right. So these are the various errors which has been reduced by the adaptive Kalman filter methods. All right. So we'll just understand how these reductions can be happened, right? By using the adaptive Kalman filter for different temperature, you can say 0 degree centigrade, at 25 degree centigrade, right? At the 40 degree centigrades. We have just reduced the RMS value and the MVA values, right? This is the actual results we have got after removing the errors from the batteries. Right? We have to develop this complete mathematical modeling equations where you have been finding out the actual state of charge. Right? We are finding we are making the predictions of the state of charge. Right? That is estimations. We have to make the estimation of the batteries. All right. So that is these are the various methods. You can go for the various methods to understand the concept. All right. So this is other methods. We have the machine learning, right? Which is based on the machine learning methods, right? Now let us see why the BMS is also important. Why we need to have the BMS, right? It will detect the unsafe operating conditions, right? So if you see that there is a what is the conditions of the each cells can be identified very easily, whether it is in a safer conditions, whether it is unsafer condition, whether any detection is happened, whether there is a chances of overheating, there is a chances of overcurrent, there is chances of the over voltage, which is limiting its optimal values, right? So for that purpose, the BMS is very essential, right? And also it will protect from your cells from the damage. It will not make it to damage very easily if you have the BMS systems, right? Because you are going to monitor each and every times. You are going to monitor all the parameters, right? And it will protect from the failure cases also, right? And there is a we don't find the chances of failure in the cells, and also we can have the life of the battery will also increase, right? And we can maintain the battery in a particular state, right? We can see what is the battery life also. We can check the battery life, right? So this is actually the block diagram for your BMS, right? You can see there is a current, there is a voltage, and there is a temperature, right? We have the data acquisitions, right? Data has been collected from this each battery cells, right? And it is given for the determination for this actual state data. It has to determine what is the state of the each cells, right? And it has to check the thermal management also. If the temperature exceeds, right? If temperature exceeds, there may have the cooling system in the batteries also, right? So that is what the many research has been happening over in the various countries, right? We are just monitoring the thermal management, right? It should not exceed its temperature limits, right? That's why we are just monitoring the temperature also. We are just monitoring the temperature also. We have to understand we should not go with the thermal runways also. If the thermal runways happens, obviously there will be the smoke, there will be the short circuit in the batteries also. Right. So this is the actual architect of your BMS, right? How the BMS will try to perform, how it will make the predictions of the battery health conditions and all, right? That is, it will try to operate in the very safety proportions. We have the many contactors electrical circuit also. When there is a excess of charge, it will try to disconnect your batteries from the actual plugging, right? It will disconnect the contacts, right? We have the electrical controlling circuit also. It will, whenever there is a thermal management runs, then it will try to disconnect the actual from through the communication CAN bus, right? It will try to disconnect the electrical contact from the charging, from the overcharging, right? So that's why the BMS is very important, right? You can see we have introduced the cooling system also, right? So each cell has been, for example, there is a thermal management, right? When you talk about this thermal management, so this is thermal management, okay? if the temperature is exceed now, okay, we just yesterday's from the data sheets we have seen that if the temperature is around 25 to it is gone to the 50-52 degree, all right, 50-52 degree. Now the cell, each cells, if you talk about the each cell, the temperature is rise to the around 50-55 degree, right? All right, so what we are supposed to do now then? If the temperature exceeds, you can see there is a battery management system. The battery management system has to give the command, right? There should have some cooling system you have to implement. So, and also you should have the contactors. The contactor will try to contact the all these cells. It will has to disconnect, right? It has to disconnect when there is a excess of heat. If the excess of heat occurs in the each cells, right? That is the each cells with the battery pack. Then you have to disconnect in a very simpler way. That's why we are using a controlling pack. So that this contactor will try to disconnect the your battery from the actual charging phenomenon, right? So that's why when it gets temperature, it gets heated up, right? So the cooling system has to be implemented. Each cells, when you pass a fluid over the each cells, right? For example, there is a thermal management. When there is a thermal management happens, what you have to do? We have to pass a fluid across the each cells. That is what we talk about the fluid dynamics. In the fluid dynamics, when you pass, because when there is a temperature, when the temperature is happening in the each cells, if you take the example in your laptop also, you take the example in the laptop, you have a lithium battery, right? So you have in the morning in the what do you say, in the motherboard of your laptop, there will be the fan will be fitted. Why? Just for the cooling purpose. The laptop should not get overheated. Yes or not? If the battery is charged for fully and the temperature is getting raised in the batteries, so that's why the processor, when the processor is also gets heated up, that's why we are fitting the fan in the your motherboard of your laptop. Similarly, when the battery, you cannot make such kind of system over in the battery pack, right? Inside the battery pack, you cannot fit like that system, right? So what you have to do in the each cells, you try to pass the fluids, okay? In the, around this, around the each cells, you try to pass the fluids so that the cooling will happen, right? So that's why we can go for the thermal management also, right? Thermal management of battery, thermal management of electric vehicles is also possible. That is one of the title you can do it in your PBL classes, okay? In the PBL, in the project based learning, you can do the how to monitor the each cells, right, from the thermal runway. So across the each cells, you can pass the fluids, right? It may be of you can use the fluid dynamics specialized. Then you can when you pass the fluid across the each cells, when gets this cells gets heated up, then the cells will try to reduce its temperature. Then you can work from the thermal, right? So meanwhile, try to disconnect the from the contactor from the charging of the each from the charging of the cells and pass the cooling system to charge the each cell, so that the cells will try to have the equal temperature. It will try to reduce the temperature to the nominal values, right? So that is how there should have the interfacing with all the other system also, so that the battery can be have certain kind of the life in the future days also, right? So this is the one thing. All right, I hope it is very clear to you. Is it clear? Okay, is it clear, Sneha?
Yes, sir.
Okay, Rashmi and Mamta, is it clear to you?
Yes, sir. Sir,
See,
which HPC method is best, sir?
see, I'm also now I'm learning on the machine learning, right? I'm just going to the machine learning because I don't want to go for these old methods. In my paper also, I've introduced in the next paper, I'm going to introduce in the for the Q1, the quarantile vines. I'm going for the cognitive learnings, right? Which is more advanced than the in your compared with the open circuit voltage or Coulomb counting methods or adaptive Kalman filter methods, right? And also the Kalman filter methods. Better you can go for the machine learnings. In the machine learning, you can go for the cognitive learnings or the neural networks. So it will try to analyze each and every conditions of the batteries all the times. If you have to train the data, first you have to train the data to the machines, then it will monitor your batteries. Okay, so better you can go for the machine learning. Is that okay?
Okay, sir.
Okay, in this paper also I've used the here I'm not using any kind of the machine learning. I'm just gone to the mathematical modeling, right? You can see I've written the more than 32 equations. So this equation we will not discuss. Okay, it is very complicated to make it to understand. Okay, From the adaptive Kalman filter methods, I have gone for the state of charge estimation for the electric vehicles, right? It is available on the internet also. If you type my name, you will get this paper. As I given here, you have to give this title. You have to type my complete name so that this paper is available on the onlines, right? In this journals of intelligent engineering and systems, right? It is under the quarantile 2 paper. It is a quarantile 2 papers. It is a repeated journals. Right, I've just developed the mathematical modeling, right? We will not discuss this all the mathematical modelings. For your syllabus, you have to understand the SOC, SOH, and BMS. That's it. That's it. Okay. So based on once you learn the BMS, we'll try to we can go for the in the simulations also. This is a completely mathematical modeling have been developed. Right. Most of the equations I have written to overcome the errors of from the batteries, right? And also this is the algorithms, right? And this is the BMS error equations, right? And this is the actual the cycle of the graph have been predicted, right? For the taking the different reference papers, right? These are the different reference paper, and these are the temperature, right? For the different temperature, have been monitor the actual value for the to remove the errors, right? If you compare with this 25 degrees centigrade in the reference number 20, paper number 20, right? They have 1.47 have been reduced to 0.51. That is the error have been removed, right? If you see for the 40 degrees centigrade of the same cells, it is 1.16 and the error is 0.31. I've been reduced because I want to increase the life cycle of the batteries, right? From the method, this is actually the mathematical modeling, right? That's why we are going for the Kalman filters, right? So the Kalman filter is more about the mathematical modeling to check the exact state of charge for the battery conditions in the especially in the EV. All right. So battery can go for the next paper. I'm working on the machine learnings, right? So in machine learning is a more advanced as compared with the adaptive Kalman filters, right? So you have to go through, you have to read most of the papers. So then only you can understand the concept thoroughly. All right. So when you start doing the PBL, no, at the end of the semester, you can go for the making the papers to publish in some good reputed journals. All right. So that method is completely more about the mathematical modeling, right? So BMS is more better. Machine learning is more better than the previous method, Kalman filter method, right? Because we have to combine the OCV and as well the Coulomb mounting methods. And so this is the method. That's why we are just not preparing this methods. We are going for the more advanced for the machine learning now. Okay. This method will try to give the actual prediction of SOC. I want to check the at what time what is the state of the battery conditions, right? So is it 70%? Is it 50%? Is it 30%? Right? I want to see the life cycle of the batteries. So that's why we have to train the data. We have to train the data to the machines. Once you train the data to the machines in the unsupervised learning, it will try to predict your SOC easily. So for that you have to develop the models. The modeling is very important. Without making any modeling, you cannot analyze any parameters. Please train the data for this. All right. In the yesterday's class, I have shown the all the data sheet. No, in the data sheet you have understood very clearly. Okay, 1 minute. I'll just show you the data sheet also so that it will be very clear to you. Okay, is it visible?
Yes, sir.
So in this, we have the aged data cells as well as the newly data cells, right? So this is the aged data cells. So with this, I have taken a lot of data from the batteries, right? So with respect to the time, right? I'm just checking the current values. I'm checking the voltage and checking temperature for the 27 degrees centigrade. Yesterday, what I have shown it was for the 25 degrees centigrade to 26, isn't 25 to 26. Now this is also the one more data for the age cells have been analyzed, which has given to the machine learning, right? The machine learning will try to, after training the data, so it will try to make the predictions. Every time it will make the try to predictions and it will give the proper data. It is monitoring, it is checking the temperature values. You can see there is a temperature is monitored properly with respect to the time as with respect to the cell voltage also. The cell voltage is also coming to be almost 3.7, right? 3.7 to 26 degrees, 3.7 to 26 degrees centigrade in terms of decimal points. So this is the data I have taken for the aged cells. So like that I have the data for the newly cells. This is the data for the fresh cells, right? Current voltage and temperature, right? We are taken for with respect to the time. I'm just identifying what is the temperature cells. Every time I want to monitor the cell temperature because cell temperature should not exceed the optimal values of the temperature. If I given, I'm just testing for the 25 to 26 degrees centigrade, right? Every time it will try to see what is the current value, what is the voltage value, right? We can see what is the current and the voltage value, right? If there is any differences, it will give me the machine learning. The machine will tell me there is a difference in the current, there is a difference in the voltage. It will give the output for me, right? So that's why I'm training the data. This data is trained to understand the machines to give the proper output and the predictions. All right, so this is the fresh shell data, right? So this is fresh shell data where we have collected the data and we have trained the data. These data are trained to the machines and machine will try to make the exact predictions. Right. So without having the data, you have to do the experimental first. Once you do the experimental from the cell monitoring, collect the data and try to put it in the Excel sheet. Then you give this data to the machine learning. Teach the machine learning to understand what the data you are providing, right? And it will give the try to develop the algorithms. Based on the algorithms, it will try to give the predictions, right? You have to design the algorithm. That is the biggest challenging things. You have to develop the algorithm for the to get the predictions. All right. So that is a very difficult jobs, right? So that is what you have to go with the in the deep learning also of the concept of the your battery management systems, right? So that's why when you we keep on learning because there is a lot of demand in the now electric vehicles for the battery management systems, right? Many people are doing the research on this. All right. So after collecting the data, please train the data to the machines. So you will get the actual value of the predictions, right? So that's why the machine learning is also very important. So that's why the machine learning in the modern days. In nowadays we are going for the AI. Yes or not? We are just going for the AI. So that is what we have to go for the AI to understand the predictions of the SOC. Correct? So is it clear?
Yes, sir.
So it will try to analyze the parameters. Every time it will going to analyze. See, if you give voltage and current, every time it is fetching the data from the batteries. Every time it is fetching the data from the battery. So these data is already taken from the aged cells as well as the fresh cells. So those data I am training to the machines. So machines I am training to this machine. Machine will try to analyze the actual data from this battery charging. Then it will estimate the SOC. So that is a more advanced methods as compared with the previous methods. Okay, this is a more advanced method. So try to go with the machine learning methods to if you want to do any research, right? So mathematical modeling is also good, but machine learning is more advanced. Right, it is more advanced. It will give the accurate results. Right, it will predict the prediction of the data is very nice. But you have to give the historical data. Without having the historical data, it will not make the any predictions. Okay, you have to train the machines. First, you have to train the machine, just like your chat GPT, right? So if you type anything, now it will give. Why? Because already we are under the supervisions, right? We are making the chat GPT to learn more and more. We are not learning. The chat GPT is going to learn the many things because in the chat GPT, all the, for example, if you type in a textbook, now it will give the all the, it will search from the entire world. All the libraries it will check because all the books have been available in the chat GPTs. It will search and it will try to analyze what the user is giving to me and it will give the outputs. That is a prediction. To make the prediction, you should train that machines to be past data has to be trained. That is how we are keeping the books in the database, right? In the database. If we want to check the textbook for any textbook, if we want to check on the electric vehicle, right? So all the electric vehicle with all the authors will be there in the database management system, right? Because it is already trained. The machines will try to understand, it will search one by one, it will search one by one, and it will give the exact result what the user wants to get the what the user expected. So that's how the machine learning will work, right? So based on that, the machine learning, you have to teach the historical data. Without teaching the historical data, you cannot make the predictions. Please, you train the machines to learn properly first. Okay. Once you train the machines to learn by unsupervised learning. So unsupervised learning means supervised learning is different and unsupervised learning is different, right? So in unsupervised learning, we are going to train the data first. Finished. Your job is done. So no more work is required. It will understand, it will learn by itself. It will train because you've been trained the data. Once you train the data, it will try to understand, it will give what the prediction it has to give. All right. So that's why the machine learning is more advanced. Okay. I hope it is clear to you. Sneha, right? Sneha, Rashmi, is it clear?
Yes, sir.
You only ask me questions. Which method is better? Sneha,
No, sir, Mamta.
Mamta, okay. So machine, you can go for the machine learning. So machine learning is the best, better methods as compared with the other methods. Okay, because you have to collect the data before you want to do any research. You please collect the data of the batteries. Without collecting the data, we cannot make any predictions. Okay, all right. So it will train the data. Once you train the data, so the prediction can be happen in a very easier way, right, in the real time. So that's why better you go for the machine learning to make the analysis and the prediction of the state of charge. All right. So this completes as a part of this state of charge. We'll understand the other things. The need of BMS I already explained, right? Why BMS is required for the safe operating conditions, right? And also detect the wherever the faulty condition occurs. The fault is nothing but the thermal increasing the temperature and overheating the cells, right? That should not be happen. So we should monitor each and every seconds of the each cells. All right, and try to protect yourself from the damage, right? And abuse of the and failure cases also can be overcome, right? And it will, if you overcome from this, there can have the prolonged life of the batteries is also possible, right? And trying to maintain the battery state all the times. This is the actual block diagrams I have shown it, right? So now let us see general function of the BMS, right? They have the sensing, right? As I told, there is a sensing unit will be there, where the sensing unit will be there across your measuring parameters, right? You can see there is a measuring parameters over here, right? Here these are the measuring parameters. If you want to measure the current, if you want to measure the voltage, if you want to measure the temperature, please fit all the sensors over here, right? So that it will try to read the values of the parameters. Okay, so that's why the sensing and high voltage control, we have to measure the voltage, current, temperature, and control contactors, right? And the detection of all the faults and thermal management, right? There should have some sensing, and the high voltage controlling unit should be there. For the protections, what are the protections we are going to make from the BMS function? Overcharging. If it gets overcharged, we have to protect from the overcharge. Don't make for the 100% ಆಗಿದ್ಮೇಲೆ ಮತ್ತೆ ಚಾರ್ಜ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಓವರ್ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಡೆಪ್ತ್ ಆಫ್ ಡಿಸ್ಚಾರ್ಜ್ ಎಷ್ಟಿದೆ 20% ಇದೆ, 20% ಆಗಿದ್ಮೇಲೆ ದೆನ್ ಯು ಕ್ಯಾನ್ ಗೋ ಫಾರ್ ದಿ ಅಗೇನ್ ಚಾರ್ಜಿಂಗ್, ರೈಟ್? ಓವರ್ ಕರೆಂಟ್ ಬಂದರೂ ಕೂಡ ನಮಗೆ ಐಡೆಂಟಿಫೈ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ಎ ಜಾಬ್ ಆಫ್ ದಿ BMS, ರೈಟ್? ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆದರೂ ಕೂಡ ಗೊತ್ತಾಗುತ್ತೆ. ಎಕ್ಸ್ಟ್ರೀಮ್ ಟೆಂಪರೇಚರ್ ರೀಚ್ ಆದರೂ ಕೂಡ ನಮಗೆ ವಿ ಕ್ಯಾನ್ ಐಡೆಂಟಿಫೈ ವಾಟ್ ಇಸ್ ದ battery conditions, right? And also you can interface the very communication protocol. That is a CAN bus. You can also communicate, right? For the data recording, all the data will be transferred to the internet over the internet, right? In the database, right? You can take the recording. You can take the recording of all the data every time, right? And also the performance of management is also possible. The state of charge estimation ಕೂಡ ನಾವು ಮಾಡ್ಬೋದು. ಯಾವ್ಯಾವ ಟೈಮಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಉಳ್ಕೊಂಡಿದೆ, 70% ಇದೆಯೋ, 50% ಇದೆಯೋ, everything we can manage very easily, right? And the power limit computation is also possible, right? And the balancing of the cell is also possible. We can equalize all the cells. ಎಲ್ಲದು cells at a time ಚಾರ್ಜ್ ಕೂಡ ನಾವು ಮಾಡ್ಬೋದು. ಒಂದು ಜಾಸ್ತಿ ಚಾರ್ಜ್ ಆಗ್ತದೆ, ಒಂದು ಕಡಿಮೆ ಚಾರ್ಜ್ ಆಗ್ತದೆ. You can see here one cell is charging more and one other cell is charging very, very less, right? In this picture you can see one cell is charging more and one cell is charging very, very less. So ಇದನ್ನು ಕೂಡ ನಾವು predictions ಮಾಡ್ಬೋದು. ಯಾವ ಥರ ಚಾರ್ಜ್ ಆಗ್ತಾ ಇದೆ, what is the condition of the each cells, we can monitor very easily if you learn the BMS. All right. If we learn the BMS, it is better we can make the analysis of the equalizing the cells, right? And the diagnostics, right? You can make the state of health also. ಯಾವ ಥರ ಹೆಲ್ತ್ ಇದೆ, ಹೆಲ್ತ್ ಕಂಡೀಷನ್ಸ್ ಯಾವ ಥರ ಇದೆ, ಇನ್ನು ಎಷ್ಟು ಲೈಫ್ ಇದೆ, ಎಸ್ಟಿಮೇಟ್ ಕೂಡ ನಾವು ಮಾಡ್ಬೋದು. ಓಕೆ, ವಾಟ್ ಈಸ್ ದ ಲೈಫ್ ಸೈಕಲ್ ಆಫ್ ದಿ ಬ್ಯಾಟ್ರೀಸ್ ಆಲ್ಸೋ ವಿ ಕ್ಯಾನ್ ಎಸ್ಟಿಮೇಟ್. All right. So these are the various reasons where you can go for the okay, where you can go for the estimation of the life of the batteries. Okay, first we can go for the diagnosis also. Remaining life ಎಷ್ಟಿದೆ ಅಂತ ಕೂಡ ನಾವು ಹೆಲ್ತ್ ಮೇಲೆ ಹೇಳ್ಬೋದು. Just I have given the example of in the previous session, isn't it? If our health is good, I can survive for next 20 years or 40 years or 50 years. Yes or not? If health is in the bad conditions, right? ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, we consult the doctor, we go for the diagnosis. Yes or not? ಏನಾದ್ರು ಹೆಲ್ತ್ ಇತ್ತಂದ್ರೆ they'll check, they'll monitor, they'll diagnose, they'll tell the what is the diseases, what is the your conditions of your health, everything it will tell, no? And based on that, if the health is good, there will be more life. Yes or not? That is the estimation we have to do. And the state of life can also be estimated in a very easy way, right? So diagnosis is very important for the batteries. That's why we have to go for the BMS. So these are the various functions of the BMS, where it is going to monitor the each cell's conditions, right? ಯಾವ್ಯಾವ ಥರ ಮಾಡುತ್ತೆ, ಓವರ್ ಪ್ರೊಟೆಕ್ಷನ್ ಇಂದ ಕೂಡ ನಮಗೆ ಹೇಳುತ್ತೆ, ಓವರ್ ಚಾರ್ಜ್ ಆಗ್ತಿದೆ ಕೂಡ ಹೇಳುತ್ತೆ, ಓವರ್ ಚಾರ್ಜ್ ಆಯಿತು ಅಥವಾ ಓವರ್ ಕರೆಂಟ್ ಬಂತು ಅಥವಾ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಅದು ಪ್ರತಿಯೊಂದು ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಗಿವ್ ದ ಇಂಟಿಮೇಷನ್ ಟು ದಿ ಯೂಸರ್ಸ್, ರೈಟ್? ಅಂಡ್ ಆಲ್ಸೋ ಎಕ್ಸ್ಟ್ರೀಮ್ ಟೆಂಪರೇಚರ್ ವೆನ್ ಇಟ್ ರೀಚ್. ಸೊ ದೆನ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಡಿಸ್ಕನೆಕ್ಟ್, ರೈಟ್? ಇಫ್ ಇಟ್ ಇಸ್ ಓವರ್ ಚಾರ್ಜಿಂಗ್, ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು disconnect from the your these control contactors, right? So that the battery can be protected, right? And also it will try to estimate the health conditions also, right? It also try to estimate the your state of charge performance. It will tell at any times. It will try to tell the state of charge performance at any time because of this BMS only, right? BMS will plays vital roles in all this functioning. So right. So now you see the architecture. The modular pack suggests a hierarchical master, that is the slave BMS design, right? There is a normally a single master unit of each pack. So if you see there is a master, you have the slave, you have the slave BMS and the slave BMS and slave BMS, isn't it? We have the master. So in this master, there is a unit of each pack will be there. So in the each pack, we have the cells and the modules will be connected inside the batteries, right? It will measure the voltage of every cell within that module. So in that module, no, you will be having the each cells. It is going to monitor the cell will be there, then the pack, then the module, then it comes the entire the pack of the batteries, right? So that is how you have to see the. It will try to measure the BMS slave will try to measure the voltage of every cell within the modules. It will measure the temperature also. It will measure the what is the energy storage, that is the balance left in the energy storage in the each every cells is within the modules. It will communicate with the information to the masters also, right? All these cells will try to monitor the cells conditions. Hello. Ready में मिल रहे हैं ताने दामा को से इंटो काला नाम चीज़ अमन फोन करा ना क्लास में से मिलूँगा. Okay, what is the role of the master BMS? It will control contactors that connects the battery to the loads, and will monitor the pack of the current, and will try to isolate the from the discharging purpose during the overcharging of the batteries, right? So that's why we are using the contactors. Control contactors will try to, when it gets overcharge, overcharge ಆಗುತ್ತೆ ಅಥವಾ exceed ಆಗುತ್ತೆ the limit, then the controller will have the isolations, right? It will try to isolate the actual part from the charging systems, right? And the master will also will do the job of the commuting with the BMS sleeves also, right? It will have the thermal measurement also. It will try to control the thermal runway of the each cells, right? And it will communicate with the other applications controller, right? If you want to transfer your data to in the with the Internet of Things in the any database management system, you can communicate with the other host also, other devices also, right? Now if you see the battery pack, right? Let us see the battery pack, the temperature sensings, right? And also the how the isolations will happen. So we have the various communication bus also, right? Okay, is it visible?
Yes, sir.
See, we do not study the what is the cell, what is the module, what is the pack, right? We should have given us a little bit introduction to you. So see, what is the difference between the cell, module, and a pack, right? So cell is just a unit. Right? It's a one unit of batteries that exert the electrical energy by charging and discharging, right? Which is made up of anode and cathode electrodes and separated with the electrolytic solutions, right? Into the maybe any aluminum case, right? So module, what is actually module? So the number of cells in a parallel or connected in series forms the module, that is the battery modules. After the number of modules composed of battery modules will connected in series in parallel will make the battery pack. Correct. So this is actually definitions for the cell, module, and a pack. Cell is a just one unit. Okay. Here the cell is a just one unit, which is doing the job of charging and discharging. Right. But module is about actually the combination of these cells, connecting the cells in series and parallel makes the module. Then all the composing of all the battery modules will makes the battery pack, which is connected in series and parallel. So you can see there is a cell. Okay. All the cells are connected in parallel and series combinations. All right. So then we are making the modules, right? If it is series in parallel combinations, to get the, if you connect in the series, right, the voltage will be very high. If you connect the cells in parallel, you will be having the more current. Okay, you will be having the more current. It depends upon the combinations how you make, right? If the 12 volts and 20 EH, right? 5 volts and so 5 volts and some other EH, which is connected in series in parallel, will tells the what current reading and what is the voltage reading of the cells. All right. So that is how you have to make the combinations and the series and parallel combination make these cells into the modules, right? So that is how they have made the modules for here, right? And all the modules are connected in series and parallel again to get the actual reading of the batteries, right? Which is connected in series, then it will make the actual pack over like this. So this is how your the packing of the cells can be seen in the especially in the electric vehicles. All right. So initially we have the cells, and cells are connected in series or parallel combination like this. Okay. Then this is made to the module, right? All the cells pack, right? All the cells pack forms the module, and these modules are connected in a series combination, right? Then it will make the complete the pack. So this is how the difference between the cell, module, and a pack. I hope it is clear to you now, right? So we have the different types of lithium, right? These are the various voltage levels, right? For the lead acids, we have 2 point voltage per each cells. For if you take the lithium, we have the around a 3.8 voltage, right? For the nickel, we have the 1.2 volt. So that's why this is the highest voltage where we are having in the most of the your laptops and electric vehicles. We are using the lithium cells only because the reading of the voltage is very high. It is around a 3.2 volts, right? So these are the types of the lithium batteries, right? We have the lithium cobalt oxides, magnesium oxides, nickel, magnesium, cobalt, iron phosphate, and titanium oxides, right? All are the families of the lithium only. Right now, about the C rate, I hope the C rate is very clear to you, which was explained in the previous sessions, right? So I have shown with the diagram week also what is the value of the C rate. That is a battery current readings, right? The current reading of the handling capacities of the batteries. For example, if you have a current charges or discharge rate which is the battery can sustain for 1 hour, right? For example, 12 volts, 20 ampere of the batteries, right? So 20 ampere can deliver at 1 hour up to ampere of the current, or for 10 hours. So that is what the C rate will decide. Actual, if the C rate is 20 ampere, then it will discharge for 1 hours, right? Or it will charge for 1 hour. If it is 2C, then 40 amperes, 40 amperes of the current will be there, or it will try to deliver, or it will try to charge for next 30 minutes. If it is a 3C, see the C rate is keep on increases, the time is getting reduced. If the C increases, the value of C increases, the time will also will reduce, and the current will also increases. So that is how the C rate is determined. Okay. If you see the C value is around 1 by 2 times of C, that is 1 by 2C. So it is taking more time, right? If the C rate is reduced, the time is also the time is increased, and the current is also decreasing gradually. So that is how the C rate can be determined. I hope it is clear. The C rate, if the C rate is very higher and it is taking the lesser time, and the current will be more. So that is what the C rate is determine the battery handling capacities of the each batteries. All right. So functioning already explained the what is the functioning of the BMS. All right. So this is the actual architect. You can take the screenshot of this, so that this is what we have discussed in the today's BMS class. You can take the screenshot of this. So any queries with these sessions? Okay. Is it clear the state of charge? Sneha, Rashmi and Mamta.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Right. So we talked about the why BMS is very important. Similarly, why SOC is very important to do the state of charge every time. Why we have to see the SOC percentage, right? It prevents the overcharging or discharging, right? We'll try to see what is the charge voltage actually, what is how much of energy is left in the batteries, how much of percentage is left over, right? It will try to improve the battery life. So based on the state of charge only, we can determine the battery life of the conditions of the each cells, right? It will protect from the batteries and will try to improve the its performance, right? If the performance is very bad due to improper state of charge, right? That is what the cell balancing, right? If the cells is not balanced properly, that may leads to the degradations also of the some batteries because of the aging factors. So that is one reasons why we have to go for the state of charge. Every time we have to check the state of charge. You have to check the percentage of what is the state of charge of the cells conditions, right? Because sometimes you may discharge, sometimes may get overcharged, right? Whenever it is get overcharged, you have to monitor what is the state of charging also and try to improve the life of the batteries. So that's why the SOC is very very important, so that you can protect the your batteries and also improve the life of the batteries also, and we'll try to improve the performance also. Every time when you are going to monitor the temperature, obviously when temperature exceeds the nominal values, right? So that you can overcome from the temperature by the thermal runaways also, and try to cool that temperature using the cooling systems, right? That is what I've shown in the previous diagram, where you can make the cooling system for your batteries also, so that you will try to improve the battery performance, right? And for the cell balancing also, we have to understand how the each cell relatives with the other cells have their in the battery chains, how they are behaving. We have to study the behavior of the cell balancing also, right? We have to balance all the cells at a time. All the cells will charge for the same percentage. If it is charging for 50 50 50, cell 1 cell 2 cell 3, that is the actual the values. That is what we have to we are expecting in the cell balancing, right? If one cell is charging for 30%, other cell is charging for 50%, other cell is charging for the 10%, that should not happen. So that to work on that, you should go for the state of charge, so that you can understand each cell condition, each cell battery conditions, cell batteries of cell condition can be checked, so that we can monitor the cell balancing in a very easier way, right? That is one of the application where you can balance the your cells also. Right. So what is cell balancing actually? It is a scheme to prevent the individual cell from the becoming the overstressed. Okay. If the cell is under the stress, no, you cannot have the cell charging because of the electrode. When the electrodes are being damaged, you cannot make the charging, and the battery is not able to accept your the charging system also, right? It will not try to charge because of the over stressed, right? You cannot charge over also. You cannot have the we can make the cell balancing if the worst stress test happen, right? The system will monitor the voltage across the each cells in the chain. So that's why you should have to learn the cell balancing. Cell balancing will tells about the what is the condition of the each cells, all right, and the relative cells of to each others in the battery chain. So that's why this cell balancing is a very important techniques to prevent the individuals from the becoming the overstressed, right? So it will try to monitor the voltage, it will try to monitor the each cells in the chains, all right? Now let us see what is the active cell balancing. So this is one of the techniques will remove the charge from the one or from or more high cells and deliver the charge to one or more low cells. So that is what it has to balance. That is what how we are going to balance. One is the active balancing, other is the passive balancing. There are two types of balancing techniques. One is the active balancing cells, other is a passive balancing cells. So in the active balancing cells, whenever there is a charge, that is some of the charge will be removed from high cells, right? So that is what you have to when it is overcharged, we have to remove the charge from the high cells and deliver the charge to the low cells, right? That is one or more low cells we have to, means we are making the, if we connect it in series, right? If you connect it in series, then you can make the active balancing in a very easier way. You try to manage the cells when it gets overcharged, when some of the cells are not being charged, try to balance the cells actively, so that the balancing of the cells can be happen in a very easier way. So this is one of the techniques where you have to remove the charge from one or more high cells, right? Then try to deliver that charge to the one or more low cells, so that the balancing can be happen in a easier way, right? So when you see talk about the passive balancing, right? If it cells with the highest charge in the pack, right? If we have the, you know what is actually the pack, right? So module, cell, module, then pack, the pack will come, right? So that indicates the higher cell of the voltage. If one of the cells is been the highest charging, and remove the excess of energy through the bypass resistor, we have the bypass resistor across the cells, okay? Across the cells, it will try to discharge. If it is overcharged, no, it will try to discharge to the resistor. So resistor where you can have the discharging capacities of the charge from the resistor. So until the voltage or charges matches with the voltage of the weaker cells. So it is just balancing. We are just going to balance passively. When it get overcharged, try to remove the cell, try to remove the charge from the through the bypassing the resistor, so that the you have to check remaining the voltages. What is the voltage of the weaker cells as well as what is the voltage of the healthy cells? Then the balancing can be happen in the passive way. That is called the passive balancing, right? So for example, if you see the charging limits, now we can see the charging limit is a protecting the battery from the effect of cell imbalance. So it is very simple to switch off the chargers when the first cell reaches the voltage which represents it's a fully charged state, right? It is 4.2 volts for most lithium cells, and disconnect the batteries when the lowest cell voltage reaches its cutoff point to the 2 volts during the discharging. So this is the charge limiting. So once you reaches the maximum values, right, of the lithium cell is around 4.2 volts. So then you have to disconnect it. If the lowest cell voltage reaches its cutoff voltage of point of 2 volts during the discharge, then you have to disconnect it. You cannot have the lesser than that voltage. It will not able to give the your charging capacity, because the voltage is reduced. Whenever the voltage is reduced, it is not able to deliver the current, right? That is what we studied in the state of charging, right? The state of charging and state of discharging. So that is when it is reaches 4.2 voltage, then it will try to discharge. So then voltage is reduced from 4.2 to 2 volts. It is not able to discharge. So that is a difficulties that we are facing in the cell balancing, right? So for that we have to go for the monitoring the all the cells, right? So these are the various methods for the cooling counting methods and the precision methods which are taken to consider of the temperature and the age of the cells as well as the cell voltage. Every time you have to monitor the cell voltage and also check the behavior of the cells temperature also, right? So because of this only we are using the Coulomb counting methods, and various methods has been adapted to identify the temperature conditions, right? We have to every time we have to balance the cells by means of any software controls or by means of any mathematical modeling or any kinds of the technique. You try to adapt and determine the state of charge of the each individual cells in the chain, or else the cell balancing, if the cell balancing is not happening, that may leads to the degradation of the batteries. All right, so these are the various methods we already discussed, right? So this is one of the method for the Coulomb counting methods. You can take the screenshot of this for the Coulomb counting methods, right? Where the method measures the discharging current of the batteries and integrates the discharging current over the time in order to estimate of SOC. We are finding the Coulomb counting method is done to estimate the state of charge at the specific time. I want to see the at the specific time what is the state of charge, right? And this is the state of at the initial stage, right? That is the values we are taking from SOC t minus of 1 plus I of t into q into delta t. So this is actually equation for finding the SOC, right? And this is actually the Kalman filter methods, right? We have the more advanced methods. We have the we'll see the state of charge and the depth of discharge, right? So depth of discharge is also the fraction of percentage of the capacity which has been removed from the fully charged batteries, or conversely for the state of charge is the fraction of percentage of the capacities still which is available in the batteries, right? So depth of discharge, I have explained in the previous sessions how the depth of discharge can also be made in a very understandable way. Okay, so it is very simple. You can understand the state of charge and depth of discharge, right? So state of charge will tells how much of percentage still it is left. Means how much of charge it is left in the battery. That is the state of charge, right? So depth of discharge is nothing but how much of charge is already been used. That is how much of charge is already been used. That will identify the depth of discharge. All right. So if the, for example, you have a water bottle, right? How do you identify the state of charge? You'll drink 20% of water, right? And remaining the 80% of water will be there. So that is called state of charge. All right. In case of depth of discharge, right? If the water is completely fully drank, right? Then what is the depth of discharge? It is zero. That is called the depth of discharge. That is a fraction of depth of discharge. How we are understanding with respect to the your drinking of water bottles, right? So state of charge will tell us about the how much of charge is still left. That is, I have given the example of the water bottle, right? In the water bottle, there is a 1 liter of water, right? In then 1 liter of water, it is 100% of water. For example, it is 100%, right? You are drinking only the 40% of the water. Then what is the percentage of water is left in the bottle? It is 60%. So that is called the state of charge. How much of charge is left? How much of water volume of the water is left in the bottle? That is called the state of charge. All right. What is the depth of discharge? The depth of discharge, it will tell how much of charge is already been used, right? Already been used. So you can say that is 40% is already been used, right? Isn't it? If the depth of discharge it is 0, then you can say the water is completely 0 only in the bottle, correct? So then you can go for the again you can go for the charging. So that is how you have to maintain the batteries, right? You have to completely charge and completely discharge. Right, that is the depth of discharge concept will tell about the percentage of the capacity which has been removed from the fully charged. It has to go to the 0 actually, right? it has to go to the 0. So then only you can go for the charging. As I told you about the 20%. Once the battery is reached to the 20%, then you try to charge the batteries again. All right. So you cannot charge when it is on 80%. So that will not makes the your cells to be balanced, and also they may leads to the overcharging also. Overnight, if you keep your battery mobile to be charged or laptop mobile to be charged for longer times, right? So it will leads to the excess of rise in the temperature. So when the temperature rise in the battery cells, no, it will try to make the degradations of your battery as soon as possible. It will try to damage your battery as soon as possible. That's why most of the times we are not is in the last sessions I explained that the battery is not giving backup means because of this reasons only. You are not charging properly, you are not discharging properly, right? We have to understand the concept of the depth of discharge, how much of charge is completely left out in the state of charge, isn't it? In the state of charge, it will tell us about the how much of charge is the remaining, right? In the depth of discharge, it will tell us how much of charge has been already been used, right? So if we talk about the 100% of SOC, right? If 0% is the depth of discharge, then what is the battery? 100% is the SOC. All right. If 0% is the depth of discharge, what is the battery conditions?
0.
No, no. Please understand the question carefully. Okay.
100%, sir.
Exactly. It is 100%. The battery is fully charged. Correct. If the 80% of SOC is there, okay, and 20% of depth of discharge, then what is the condition of the battery? Can you tell me what is the depth of discharge? For example, if the state of charge is 80%, okay, if the state of charge is 80% and the depth of discharge is 20%. So how much of charge is left again? What is the capacity of the battery? To make the 100% of SOC, again you should have to charge for the 20%, isn't it? So depth of discharge is SOC is 80% now and depth of discharge is 20%. It means the 20% is already been used. Okay, that is the 20% is already been used. If the depth of discharge is around 20%, right? If the 20% depth of discharge it is there, then you can predict that the 20% of the capacity has been already been used. Correct? That is how you have to calculate. All right. For you have given the answer for the exactly for state of charge. If the state of charge is 100%, 0% is the depth of discharge, then you can say the battery is full. Correct? That is how you have to calculate the depth of discharge and the state of charge. So all right. So we'll go to the conclusion part, right? So most of the batteries are the core energy source in the EVs because the battery is the heart of the electric vehicles. As I told, without batteries you cannot run any vehicles. It is very difficult to run your vehicles because the battery is nothing but the it's just like a fuel for your electric vehicles. Just like how we are using for the petrol and diesel for your IC engine, the battery is also like a fuel for your electric vehicles. So all right. So that is the reasons where you have to see the battery is the core energy for the source in electric vehicle and heavy electric vehicles, right? And their performance greatly impacts the scalability of the electric vehicles. All right. So that's why every manufacturer has to go through the battery technologies because the battery is a part of the electric vehicles. If the battery fails, for example, if the battery fails, it is not possible to drive your vehicles. Correct? It is just like a heart. The heart and the brains of the human body, right? That will never sleep. Correct? Your heart and the brain will never sleep, and the rest of the part will sleep because the heart has to pump the blood, right? The brain has to think. And if you sleep in a dream also, you'll get the. If you sleep in the night also, you'll get the dreams because the brain is also still working, and heart is also trying to pump your bloods. So that's why I just compare the battery to the heart. Isn't it? So battery is the heart of the electric vehicles. So without that, you cannot communicate. There is no communication bus. There is no driving movement. There is no vehicle will not move. There is no transporting. There is no chances of moving the vehicles only if you don't have the batteries. So battery must have the. It is just like a fuel for your electric vehicles. So all right. So all the manufacturer has to. They have to understand. They have to try to implement. They have to improve the technology of the batteries also, and try to improve the BMS also, right? So that will help us to make the battery to be more improvised with the different techniques, right? BMS is very important. As I explained, BMS, why BMS is required because of the thermal runway in the some of the flights, the 786 flights, which has got the catch the smoke on fire and get short circuited. Then only the concept of the BMS was introduced in the batteries, right? So battery management system is a very important, which plays important roles in the electric vehicles, right? When we talk about the major concerns, the discussion about the and this presentation, we talk about the real world applications of. We need to find a lot of solutions, right? Uh, which is very required for the improve the battery health of the batteries also, right? So based on these, the various methods should be applied, right? So we have the various method we studied, right? The open circuit voltage we studied, right? We studied the Coulomb counting methods. We have studied the Kalman filter methods. We have studied the adaptive Kalman filters. We have studied. We have studied the machine learning. So these are the various strategies. We have to see the various strategies and try to apply this to improve and optimize the performance of your the battery vehicles for the future EV and EV vehicles also, right? So if you have any queries, you can ask me. Mamta, Rashmi, Sneha. Okay, if you have any queries, you can ask me. We'll make the discussions. Yes, Sneha.
No doubt, sir.
Is it the concept is clear?
Yes, sir.
Mamta.
ಸರ್ ಎಸ್ ಒ ಸಿ ಮೆಥಡ್ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಮತ್ತೆ ಇಂಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಅಂತ ಹೇಳಿದ್ರಿ. ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಅಂದ್ರೆ ಏನು ಸರ್? ಇಂಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಎಸ್ ಒ ಸಿ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ.
SOC is the direct method, right?
ಎಸ್ ಸರ್.
See, in the direct method, we are just finding only the voltage and its impedance and the current. We are not focusing more on the temperature, right? That is what I have explained in the very most first methods. Right, I'll show you that slides. Right. So because what is happening over here actually in the direct methods, you can see this method you are predicting only the voltage and current. Okay. So voltage current ಮಾತ್ರ prediction ಮಾಡ್ತಾ ಇದ್ದೀರಾ ನೀವು, but you are not focusing on the temperature. So temperature ಯಾವಾಗ ಫೋಕಸ್ ಮಾಡ್ಬೇಕು ನೀವು, ಲೋಡ್ ಆಗಿದಾಗ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಜಾಸ್ತಿ ಎಳಿತಾ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಫ್ರಮ್ ಬ್ಯಾಟ್ರಿಯಿಂದ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಜಾಸ್ತಿ ಡ್ರಾ ಮಾಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ. ಸೊ ಡ್ಯೂರಿಂಗ್ ದಟ್ ಟೈಮ್ ದ ಎಕ್ಸಸ್ ಆಫ್ ವೆನ್ ದ ಕರೆಂಟ್ ಈಸ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದಿ ಯುವರ್ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆ್ಯಂಡ್ ದ ಟೆಂಪರೇಚರ್. ಸೊ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಆಲ್ಸೋ ವೇರೀಸ್. ಅದು ನಾವು ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಫೋಕಸ್ಸೇ ಮಾಡ್ತಾ ಇಲ್ಲ. ವಿ ಆರ್ ಜಸ್ಟ್ ಟೇಕಿಂಗ್ ದ ಪ್ಯಾರಾಮೀಟರ್ ವೋಲ್ಟೇಜ್ ಅಂಡ್ ಕರೆಂಟ್. ವೋಲ್ಟೇಜ್ ಅಂಡ್ ಕರೆಂಟ್ ಮೇಲೆ ಚೆಕ್ ಮಾಡ್ತಾ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ನ ಕಂಡುಹಿಡಿತಾ ಇದ್ದೀವಿ. ಬಟ್ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ನಾವು ಒಂದು ಸಲನೂ ಫೋಕಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ವಿ ಆರ್ ನಾಟ್ ಫೋಕಸಿಂಗ್ ಮೋರ್ ಆನ್ ದ ಟೆಂಪರೇಚರ್. ಟೆಂಪರೇಚರ್ ಈಸ್ ಆಲ್ಸೋ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದಿ ಚೇಂಜ್ ಇನ್ ದ ವೋಲ್ಟೇಜ್. ಟೆಂಪರೇಚರ್ ಯಾವಾಗ ನಿಮಗೆ ವೋಲ್ಟೇಜ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಟೆಂಪರೇಚರ್ ಕೂಡ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಎಸ್ ಆರ್ ನಾಟ್? ಈಗ ಟೆಂಪರೇಚರ್ ಈಗ ವೋಲ್ಟೇಜ್ ಅರೌಂಡ್ 4.2. ಸೊ ವಾಟ್ ಇಸ್ ದ ಟೆಂಪರೇಚರ್? ದೆನ್ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಟು ದ 2.4 voltage. Then what is the temperature? Are you monitoring that one? You are not monitoring only. You are just monitoring only the direct methods in the measurement ಅಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಕರೆಂಟ್ ಮಾತ್ರ ತಗೊಳ್ತಾ ಇದ್ದೀರಾ ಹೊರತು, ಬಟ್ ವೋಲ್ಟೇಜ್ ಜೊತೆಗೆ ಟೆಂಪರೇಚರ್ನ ಮಾನಿಟರ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಸೊ ದಟ್ ಇಸ್ ಡ್ರಾಬ್ಯಾಕ್ ಇನ್ ದಿಸ್ ಮೆಥಡ್ಸ್. ಸೊ ದಟ್ಸ್ ವೈ ದಿಸ್ ಅಪ್ರೋಚ್ ಈಸ್ ನಾಟ್ ವೆರಿ ಫಿಸಿಬಲ್ ಟು ಡೂ ಯುವರ್ ರಿಸರ್ಚ್. ಸೊ ದಟ್ಸ್ ವೈ ದಿಸ್ ಮೆಥಡ್ ವಾಸ್ ಫೇಲ್ಡ್. ಯಾಕೆ ಮೆಥಡ್ ಫೇಲ್ ಆಗಿದೆ ಅಂದರೆ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಅವರು ಫೋಕಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಬಿಕಾಸ್ ವೆನ್ ದೇವರ್ ದ ವೋಲ್ಟೇಜ್ ಲೋಡ್ ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಲೋಡ್ ಕಂಡೀಷನ್, ರೈಟ್? ಸೊ ಕರೆಂಟ್ ವಿಲ್ ಏಬಲ್ ಟು ಡ್ರಾ, ರೈಟ್? ವೆನ್ ಕರೆಂಟ್ ಈಸ್ ಡ್ರಾಯಿಂಗ್, have told about the graphs also, right? So a graph I have clearly explained that with respect to the age, which is on the x-axis, right, and the current in the y-axis, right? We are checking the state of health. ಅಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ನ ಮಾತ್ರ ಚೆಕ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ವಿ ಆರ್ ನಾಟ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇನಿಷಿಯಲಿ ತೊಗೊಂಡು ಬಂದಾಗ 50 H ಇತ್ತು. ಓಕೆ, 50 H ಇತ್ತು. ಯಾವಾಗ ಸ್ಟಾರ್ಟಿಂಗ್ ನೀವು ಸ್ಟಾರ್ಟಿಂಗ್ ಇನ್ನು ಬ್ಯಾಟ್ರಿನ ತಂದಿದ್ರೆ ಅವಾಗ 50 H ಇತ್ತು. ಸೊ ದಟ್ ವಾಸ್ ದಟ್ ವಾಸ್ ದ ಏಜ್. ಓಕೆ, ಇವಾಗ 100 ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಆಯಿತು. ಅವಾಗ ಏನಾಯಿತು, 100 ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಆದಾಗ 50 H ಇಂದ ಏನಾಯಿತು 45 H ಗೆ ಬಂದುಬಿಡ್ತದೆ. ಓಕೆ, ಆಫ್ಟರ್ 200 ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಆಯಿತು, ಚಾರ್ಜಿಂಗ್ ಆ್ಯಂಡ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಆಯಿತು. ದೆನ್ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಟು ದ ಅಗೇನ್ 30 H ಆ್ಯಂಡ್ ದೆನ್ ಇಟ್ ಇಸ್ ಅಗೇನ್ ರಿಡ್ಯೂಸಿಂಗ್ ಟು ದ 20 H. ಸೊ ಕರೆಂಟ್ ಏನಾಗ್ತದೆ, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಿಡ್ಯೂಸ್ ಆಸ್ ದ ವೋಲ್ಟೇಜ್ ಆಲ್ಸೋ ಗೆಟಿಂಗ್ ರಿಡ್ಯೂಸ್. ವೋಲ್ಟೇಜ್ ಯಾಕೆ ರಿಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ದೇರ್ ಇಸ್ ಎ ಚೇಂಜ್ ಇನ್ ದ ಟೆಂಪರೇಚರ್. ದ ಕರೆಂಟ್ ಈಸ್ ಗೆಟಿಂಗ್ ಯಾಕೆ ರಿಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ, ದ ಲೋಡ್ ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಲೋಡ್ ಟು ದ ಮೆಷಿನ್ಸ್, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ದ ಮೋಟರ್ ಏನು ಮಾಡುತ್ತೆ, ಕರೆಂಟ್ ಜಾಸ್ತಿ ಡ್ರಾ ಮಾಡೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. ಕರೆಂಟ್ ಜಾಸ್ತಿ ಡ್ರಾ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಏಜ್ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಏಜ್ ಕಡಿಮೆ ಆದಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ವೋಲ್ಟೇಜ್ ಕೂಡ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇಟ್ ಬಿಕಾಸ್ ಸೈಕಲ್ ಇಸ್ ಆಲ್ಸೋ ಗೆಟಿಂಗ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ಯುವರ್ ಕರೆಂಟ್. ಬಿಕಾಸ್ ಕರೆಂಟ್ ಏನಾಗುತ್ತೆ ಆಂಪಿಯರ್ ಅವರ್ಸ್ ಮೇಲೆ ಕೂಡ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಆಂಪಿಯರ್ ಅವರ್ಸ್ ಆಲ್ಸೋ ಇಂಟೆನ್ಸ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ಯುವರ್ ಟೆಂಪರೇಚರ್ ಆಲ್ಸೋ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ವೋಲ್ಟೇಜ್ ಆ್ಯಂಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಲೋಡ್ ಕಂಡೀಷನ್ಸ್. ಬಟ್ ಯು ಆರ್ ನಾಟ್ ಫೋಕಸಿಂಗ್ ಮೋರ್ ಆನ್ ದ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ನೀವು ಏನು ಆಗ್ತಿದೆ ಅನ್ನೋದೇ ನೋಡ್ತಾ ಇಲ್ಲ. ಸೊ ದಟ್ಸ್ ವೈ ದಿಸ್ ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಈಸ್ ನಾಟ್ ವೆರಿ ಸಕ್ಸಸ್ಫುಲ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಫಿಸಿಬಲ್ ಟು ಡೂ ಎನಿ ರಿಸರ್ಚ್. ಟೆಂಪ್ರೇಚರ್ ಇಲ್ದಂಗೆ ನೀವು ಮಾನಿಟರ್ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ. ಯಾಕಂದರೆ ಟೆಂಪ್ರೇಚರ್ ಯಾವಾಗ ಬೇಕಾದರೂ ರೈಸ್ ಆಗ್ಬೋದು. ಚಾರ್ಜಿಂಗ್ ಮಾಡೋದು ಓವರ್ ಚಾರ್ಜ್ ಮಾಡಿದ್ರಿ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಒಂದೊಂದ್ಸಲ ಲ್ಯಾಪ್ಟಾಪ್ನ ಓವರ್ ಚಾರ್ಜ್ ಮಾಡ್ತೀರಿ, ನೀವು ಸಿ ದ ಮದರ್ ಬೋರ್ಡ್ ಆಫ್ ದಿ ಯುವರ್ ಲ್ಯಾಪ್ಟಾಪ್ಸ್ ಬಿಸಿ ತುಂಬ ಹೀಟ್ ಆಗಿರುತ್ತೆ. ಯಾಕೆ ಹೇಳಿ, ಬಿಕಾಸ್ ಆಫ್ ಓವರ್ ಚಾರ್ಜಿಂಗ್. ಕರೆಂಟ್ ಜಾಸ್ತಿ ಎಕ್ಸೆಸ್ ಆಫ್ ಓವರ್ ಚಾರ್ಜಿಂಗ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ರೈಸ್ ಆಗುತ್ತೆ. ಸೊ ಯು ಆರ್ ನಾಟ್ ಫೋಕಸಿಂಗ್ ಮೋರ್ ಆನ್ ದ ಟೆಂಪ್ರೇಚರ್ ಬಿಕಾಸ್ ವೋಲ್ಟೇಜ್ ಈಸ್ ಆಲ್ಸೋ ಚೇಂಜಿಂಗ್. ಸೊ ಸಮ್ಟೈಮ್ ವೋಲ್ಟೇಜ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಟು ದ ನಾಮಿನಲ್ ವ್ಯಾಲ್ಯೂಗಿಂತ ಜಾಸ್ತಿ ಆಗಿಬಿಡುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಟೆಂಪ್ರೇಚರ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So that is the reasons this method is not very successful and not feasible also. That's why we cannot estimate properly. State of charge ಹೇಳುತ್ತೆ, ಬಟ್ ಎಸ್ಟಿಮೇಷನ್ ನಾವು ಕರೆಕ್ಟಾಗಿ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ. ಟೆಂಪ್ರೇಚರ್ ಮಾನಿಟರ್ ಮಾಡಿಲ್ಲಂಗೆ ನಾವು ಪ್ರೆಡಿಕ್ಷನ್ಸ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ದಟ್ಸ್ ವೈ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ಪ್ಯಾರಾಮೀಟರ್ ಆಫ್ ಟೆಂಪ್ರೇಚರ್. ಸೊ ದಟ್ಸ್ ವೈ ಐ ಹ್ಯಾವ್ ಶೋನ್ ಇನ್ ದ ವೆರಿ ಮೋಸ್ಟ್ ಫಸ್ಟ್ ಆರ್ಕಿಟೆಕ್ಟ್ BMS ಆರ್ಕಿಟೆಕ್ಟಲ್ಲಿ ನಾನು ಅದನ್ನೇ ಹೇಳಿರೋದು ನಿಮಗೆ. ವಾಟ್ ಆರ್ ದ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸೆನ್ಸ್, ವಿ ಆರ್ ಸೆನ್ಸಿಂಗ್ ದ ಕರೆಂಟ್, ಟೆಂಪ್ರೇಚರ್ ಆ್ಯಂಡ್ ದಿ ವೋಲ್ಟೇಜ್. ಓಕೆ, ಐ ವಿಲ್ ಶೋ ಇನ್ ದ ಫಸ್ಟ್ ಸ್ಲೈಡ್ಸ್, ವೆರಿ ಮೋಸ್ಟ್ ಫಸ್ಟ್ ಸ್ಲೈಡ್ಸ್. It is here only, almost it is here, right? See, understood? See, ನೋಡಿ ಏನೇನು ತಗೊಳ್ತಿದ್ದೀರಾ, ಥರ್ಮಲ್ 1, ಥರ್ಮಲ್ 2, isn't it? ಥರ್ಮಲ್ 1 ಅಂದ್ರೇನು, ಟೆಂಪರೇಚರ್ ಆಫ್ one cell, isn't it? So temperature of other cells, this is the current you are taking, you are sensing the current from each cell. ಪ್ರತಿ ಸೆಲ್ಸ್ ಇಂದ ನೀವು ಟೆಂಪರೇಚರ್ ತಗೊಳ್ತಾ ಇದ್ದೀರಾ, ಬಟ್ ಟೆಂಪರೇಚರು ನಿಮ್ಮ ಯಾವುದೂ ಡಿಪೆಂಡೆಡ್ ಆಗಿದೆ. ಇಟ್ ಇಸ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ಯುವರ್ ವೋಲ್ಟೇಜಸ್, right? The temperature and the because of the variations in the voltage, because due to the when you apply the load on the vehicles, the voltage will also change, then the temperature will also rise. It is also not only happen during the running conditions, it will also happens in the during the charging also. Over charging ಆದರೂ ಕೂಡ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ವೋಲ್ಟೇಜ್ ಕೂಡ ಎಕ್ಸೆಸ್ ಆದರೂ ಕೂಡ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ವೇರಿಯೇಷನ್ ಚೇಂಜ್ ಇನ್ ದ ವೇರಿಯೇಷನ್ ಇನ್ ದ ವೋಲ್ಟೇಜ್ ಆದರೂ ಕೂಡ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಆಲ್ಸೋ rise. So because of this only the direct method was failed. That's why we are not we are not using that methods. Okay, so ಆ ಮೆಥಡ್ನ ಯಾಕೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂದರೆ we are not focusing more on the your temperature part. So that is the reasons. So is it clear?
Okay, sir. Thank you.
Right, ಬೇರೆ ಮೆಥಡಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಿದ್ದೀವಿ, we are checking all the with respect to the temperature also, right? In other methods you can see we are just monitoring the temperature. BMS ಆರ್ಕಿಟೆಕ್ಟಲ್ಲಿ ಎಲ್ಲದೂ ನಾವು ಮಾನಿಟರ್ ಮಾಡ್ತೀವಿ, ಯಾವ್ಯಾವ ಥರ ವೇರಿಯೇಷನ್ಸ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದು. ಟೆಂಪರೇಚರ್ ನೀವು ಸೆನ್ಸ್ ಮಾಡ್ತಾ ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ವಿತ್ ದ ಟೆಂಪರೇಚರ್, ನಾಟ್ ಅನಲೈಸಿಂಗ್ ಇನ್ ದಿಸ್ ಮೆಥಡ್ಸ್. ಬಟ್ ಬೇರೆ ಮೆಥಡಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅನಲೈಸ್ ವಾಟ್ ಈಸ್ ಆ್ಯಕ್ಚುಲಿ ಹ್ಯಾಪನಿಂಗ್ ಇನ್ ದ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೆಂಪರೇಚರ್. ಐ ಶೋನ್ ದ ಡೇಟಾ ಶೀಟ್ ಆಲ್ಸೋ. ಡೇಟಾ ಶೀಟಲ್ಲಿ ನೋಡಿ ಟೆಂಪರೇಚರ್ ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಬರ್ತಾ ಇತ್ತು, ಟೆಂಪರೇಚರ್ ವೇರಿಯೇಷನ್ಸ್ ಆಗಲಿಲ್ಲ. 25 ಇಂದ 26 ಬರ್ತಾ ಇತ್ತು. ಕರೆಂಟ್ ವೋಲ್ಟೇಜ್ ಕೂಡ ವೇರಿಯೇಷನ್ಸ್ ಆಗ್ತಾ ಇತ್ತು, ರೈಟ್? ಸೊ ದಟ್ಸ್ ವೈ ಡೈರೆಕ್ಟ್ ಮೆಥಡಲ್ಲಿ ನೀವು ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಜಾಸ್ತಿ ಫೋಕಸ್ ಮಾಡೋದಿಲ್ಲ. ವಿ ಆರ್ ನಾಟ್ ಫೋಕಸಿಂಗ್ ಮೋರ್ ಆನ್ ದ ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ಸ್ ವಿ ಆರ್ ನಾಟ್ ಪ್ರಿಫರಿಂಗ್ ದಿಸ್ ಮೆಥಡ್ಸ್. ದಟ್ಸ್ ವೈ ದಿಸ್ ಮೆಥಡ್ is nobody using this methods, right? You can go for the Coulomb counting methods also, you can go for the other parameters, other methods also, like Kalman filters ನೋಡ್ಬೋದು ನೀವು. And also you can check the Kalman filter also. We are checking the this one temperature. We are observing the what is happening in the machine learning also. Machine learning also is the best methods to analyze your state of charge. So is it clear, Sneha or Mamta?
Yes, sir.
So that's why you should prefer for the machine learning one. That is a better. You can monitor each and everything. So BMS ಅಲ್ಲಿ ಎಲ್ಲದೂ monitor ಮಾಡಬೇಕಾಗುತ್ತೆ. Right? If you see in the depth, if you study the chemical behavior of the fabrication of the cells also, electrode ಕೂಡ ನಾವು monitor ಮಾಡಬೇಕಾಗುತ್ತೆ. ನಾವು ಅದನ್ನೆಲ್ಲ we are not studying in the part of the chemical. We are just analyzing only the electrical parts, right? ನಾವು electrical part ಮಾತ್ರ ನಾವು study ಮಾಡ್ತಾ ಇದೀವಿ. We are not analyzing with the chemical chemistry part of the batteries. right? ಎಲೆಕ್ಟ್ರೋಡ್ ಯಾವ ಥರ ಇದೆ, ಎಲೆಕ್ಟ್ರೋಡ್ ಬಿಹೇವ್ ಟೈಪ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅದನ್ನ ಯಾವ ಸ್ಟಡಿ ಮಾಡ್ತಾರೆ. ನಮಗೇನು ಬ್ಯಾಟ್ರಿದು ಹೆಲ್ತ್ ಕಂಡೀಷನ್ ಬೇಕೋ, ಚಾರ್ಜಿಂಗ್ ಕಂಡೀಷನ್ ಬೇಕು, ಡೆಪ್ತ್ ಆಫ್ ಡಿಸ್ಚಾರ್ಜ್ ಬೇಕು ಅಷ್ಟೇ. ಅಂದರೆ ಬ್ಯಾಟ್ರಿ ಮ್ಯಾನೇಜ್ ಸಿಸ್ಟಮ್ ಯಾವ ಥರ ಇದೆ, ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಇನ್ ದ ಸಿಲೆಬಸ್, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಅಂಡರ್ಸ್ಟುಡ್ ದ ವೇರಿಯಸ್ ಮೆಥಡ್ಸ್ ಟು ಅನಲೈಸ್ how the state of charge can be happen with different methods. Okay, is it clear? Shall I wind up the class?
Yes, sir.
Okay, I'll wind up the class at we'll study the state of health in the next sessions, okay?